Hello.
Hi, good morning.
Hi, good morning, everyone.
Second, mute my computer. Hello. Morning. How are you guys?
Good, good. You?
Not bad. Yes, Switzerland is not so good, but I'm well. We might need to change a bit the schedule today. I think Michael and Samira won't be able to won't be ready to present. So we can like postpone the afternoon session, like start at 2 or something, and then maybe have the coffee break earlier in the afternoon as well. If it's not like, yeah, I think we can still have like a coffee break at 3:30. Maybe we could just get more time for the speakers in the afternoon. But we can start like at 2 after lunch. I will change the schedule if Chunshui, Aksa, Laila, and Anna is okay with it. Let's wait a bit if they are all here. Okay. Sorry. Hello. Yeah. You guys want to take the group picture first or after? Hello. Oh, okay. Now it's my YouTube talking. I was thinking of that. The sound is so familiar. Get connected. Wait a bit. So we all still wait maybe a couple of minutes because now we don't have, seems like we only have 13 people. Andre is not here yet. But just to remind you guys again, please upload your slides into the folder I sent you before yesterday.
Yeah, and I suppose it's the same folder that you sent it before, no?
Yes.
Okay.
How about if I'm still updating the presentation? Do I wait until I'm ready or?
You are still up.
Yeah.
Okay, maybe after. I think you already have one version, right? So.
Yeah, I sent one version, but I needed to make some correction of those.
Maybe after that then.
Yeah. Okay. Fine.
Thank you. 14 people. So, okay, Andre is not here yet, but let's start like 9:35. Let's just fill in the name and the institution. So attendance list, I have filled in before, but like some of them might not be here today. Okay. Treasury, you're here, right? And Excel?
Yes.
Excel is not. Laila, you're here, I think. Yes. And Anna. Yes. Okay.
Yes, yeah, yes. I need to update the presentation. I'll do it now.
Oh, okay. And one thing.
Yeah.
So for the speaker in the afternoon,
Yeah.
we might start later, like at 2. Start at 2
Yep.
and
2 is fine.
postpone like 30 minutes. Is that okay for you guys?
Yeah, sure.
It's okay for me, but I will have to leave at I have something at 14:45, so I don't know if I can keep the same schedule.
Okay. You have you have something to do at 2:45, you mean?
Yeah, I have a quick I have to see with my PhD tutor, so.
I see. Treasury, would you mind to switch with her, with Laila?
Yeah, I'm okay.
So you go to the third slot. Laila
So
goes at 2.
2.
No. Treasury, you
2:40.
will be okay. Maybe I will change it right now.
Okay.
Makes more sense to do like that. So let's say because we have like 2 speakers won't be able to speak to talk today. So this will be Laila. sorry about the short notice, but I just got this news today. So
Thanks for changing.
yeah. Okay. Yeah. So it will be like that. Is that okay for you guys? I'm not sure if Axel is here. Not yet. Okay. Then anyway, I will start. I think Andre is not here yet. Let's just start. So, good morning, everyone. Thank you so much again to Tony Yang, especially at this difficult time. Today it's our fourth workshop. Okay. So so first of all, I will have this welcome, like what's the progress so far and what they plan in the future. And then I will have a discussion about some of my plots of the paper. Then hopefully we can have the draft ready by next workshop, which is December 15th. I think I sent out the emails to you guys, and it will be on December 15th, and we will hopefully can edit the draft by then. And yeah, so this will be still like last time. We will have the updates from all the participants, and then in the end, maybe we will have some Q&A for the Sophie, for the rolling PMF in general, and for your talks, you can also talk a bit what kind of question you have encountered so far, and then we can also try to help well during the meeting. So again, just remind you guys to upload your slide here, and it's on live in the YouTube as usual. So here, okay, I need to delete this. Okay, here it is. So far we have this much progress. I think compared to last time, most of the rolling, PMF are still in progress still, but I'm sure as far as I know, they are still advancing, at least made some progresses, of course. And I believe in Helsinki, this one should be ready. And but others, I haven't looked into it yet. We'll see what we can, how many yellows could Tim bring by after this workshop. Yeah, and for whoever is not ready yet, I highly recommend you guys to send me an email to schedule a regular meeting lately. Then we can help you as much as possible. Then we can hopefully have some preliminary results by the end of this month as planned. Yeah, so this is the plans. Just to remind you again, we have today is our fourth workshop. It's more about presentation, and we said the end of this month we'll have preliminary results. And we do have some STSN visitors at PSI. So Olga and Samira, I mean, Samira was here, but she has to go back. Olga is still here, but she's also has to go back by today. It's not like it's not I mean, as planned, but at least we have accomplished something, and hopefully we can finalize those results soon. And at the moment, we are still, so at PSI, we're still not allowed to host any visitors. But hopefully, you know, if the situation gets better, then might be still possible, but yeah, it's less likely. As I said here, we will have our 5th workshop in December 15th. So it will be more about this result discussion, and hopefully we can edit the manuscript together. And then our goal is to submit by the end of March, hopefully. And during this last workshop, we wanted to finalize the result, finalize the manuscript. So, and I have list something here for unfinished sites. I have some suggestions and what the status right now. Maybe I will go. I can change this later after this workshop, but that's what in my mind or so far. Correct me if maybe change my mind after the workshop. Yes, so that's the overview for the progress so far. Let's go to the other one. Okay. Any questions? Any comments? No? Do you have something to add, Mary Cruz? I think Andre is not here yet, so maybe it'll be good if you can.
No, not really.
Okay. Then we go to the next part. So I think. Wait, okay. So compared to the last time, I do not have the new results, let's say. I mean, I didn't get the results from you guys yet. I guess it's not ready. But like I have put something maybe we can discuss today. Basically how this paper should be structured. So I think in the introduction, we can talk about those things. Like what's the status of parental air quality, why we are doing this motivation basically, and a bit research, literature review, and then we talking about why we are doing this, the research gaps basically, and then what can be done and why is it useful to discuss those things in the introduction, and also talk about our data coverage, introduce the campaign we have done, and of course the data we have. And for the methods, I think One thing is how we did the fail campaign. I think maybe I'm not sure if everyone was following the SOP while doing the campaign. But like, I guess if it's published somewhere, we can still cite it. And here the master will be just talking about the PMF ME2 and the rolling PMF and the SOP Pro. So for rolling PMF SOP Pro, Francesco's paper is out, and then my paper will be out soon. So it should not be like have too much contents on this part. Just cite it should be sufficient. And yeah, for this, I will have the protocol provided in the SI probably. I mean, I guess you have all seen the 7th version of the protocol. I have provided a criterion list, so maybe it will be worthwhile if you guys can go through it somehow. And I mean, if you find something need to be improved, just let me know. Yeah, so if find something confusing, should also let me know, then I can improve this protocol as much as I can. Then I think the research questions for this paper will be, first of all, how well the protocol works and how early basically spatial variabilities of the O resources in Europe, and then the temporal variations of the OS sources in Europe. And then what we want to discuss is what's the implication of this to the modelers and policymakers, and what are the limitations for this work, and what could be done in the future, improved in the future. Those are I think this could be the messages for the paper, but I guess we still need to know in more details about what are the temporal and spatial variabilities of those really are. And I think you have seen this many times. I don't need to explain. Just saying, oh, this figure could be answer one of the question right here, the spatial variabilities. And then this is the temporal variabilities, relative contributions for different sites. And here, I mean, this is more, this is like also a spatial variabilities, let's say. But I think last time Andre suggested to, you know, to instead of doing the intercolumn range and the median, we should really put everything in it. That's what he told me, but I'm not sure how it looks like yet. And yeah, so this is a diagonal, and we can also do it through the weekly cycle. But the question is, how can do we need to do it like in different seasons as well? This is just yearly average. And do we need to do like to do some case studies for some of the overlapped period? Those are still the questions I have, at least from my side. And this is weekly cycles, and then maybe the yearly average profiles. I think the definition of HOA we still need to improve somehow, because at least I think the HOA in Huchiala, I don't know. I mean, I think maybe we still need to look into it. I mean,
at least I was calling it just POA because it
Yeah.
was resembling both, so the
Yes.
naming. And I think the results you have are quite old, so I will
Yeah.
send you the new ones.
Okay. sounds good. Yeah, so we need to, I think one of the question I got from my colleagues are, oh, this HOA is supposed to be quite stable over different different places. Why they have so high error bars? So I guess that's because when I define the HOA, maybe we need to be more cautious about this. And also the BBOA, I think I think it's rather okay by just looking at this error bars. But yeah, but we'll see after all the results were updated. And this is for the cooking factors. Here it has four sites: Barcelona, Athens, Zurich, Marseille. I think 5 sites because Zurich have 2 instruments. Oh, sorry, Athens have 2 instruments. One is Q, the other is TOF. And the LV and SV. So, or maybe we say it's LO and MO. So it's just a matter of how we named it. And maybe this plot as well. I'm aware that the Peeber effect is not always corrected, but I'm not sure if this makes sense to do. I mean, if it makes sense to do this at all. But I mean, the Peeber effect won't be corrected completely anyway, and some of the data sets cannot correct it because I think they did not do the calibration back then, so the post correction won't make sense at all. But yeah, so I'm just wondering if this makes sense to do this. And maybe one thing we could do is to plot the 44/43 ratio as a function of temperature or latitude. That's I haven't done yet, but maybe it's an option. Yes, so any thoughts? Any suggestions? No? I'm trying to take notes, so just tell me if you have any questions or suggestions. Will be really good here.
At least I like this this plot, this F44 versus F43 during different with different cities or countries. But of course, it will be interesting to see how this temperature or latitude affect, or if you could somehow color coded them according to latitude.
Maybe also the size could use the size to indicate.
Yeah.
I think color code should be also doable. I over the limit already.
Just more formality, aren't we gonna call it more oxidized and less oxidized?
Okay, yeah. I mean, mine's as well. Yeah, for the Magdino, we will also call it like more oxidized and less oxidized. But as also for this, do we do it like, should we do it also season-wise? Because it might change quite a bit as well. This is just yearly average.
Maybe we can put some information in supplementary material.
Yeah.
Yeah, and actually, for Bucharest case, we don't have LV or SV for all the seasons. We have just for 2 of them.
Yeah, I see.
So it's a little bit tricky. You can put OA
I
or
think it's still, I mean, just put another shape, then the
yeah.
O could be there as well. Okay. Anything else we should discuss? Or is anyone happy with the plan or schedule deadline? Or should I go through in more detail about this for the unfinished sites? I mean, we can talk about this, I guess. I think for Athens, Olga is here, and we have bi-weekly meetings since May, and I think it should be finished within a month, right? Yeah. Please show your face. Yeah, okay. And the brokenness, I think Stefan's not here, but I think it should consider contact Francesco for the PMF service, like running PMF for them. And Bucharest, I think you should be able to finish soon, right?
Yeah, I think also actually I just had some trouble because I had 2 hours from March in the winter running, so I should do it again. But I think next week I'll be able to finish. You will see more on my presentation.
Okay, sounds good.
But also, it will be really nice if we can meet and look together at the results because I'll be more confident on them.
Sure, not a problem. We
Thanks.
can for sure schedule the meeting. And for Axel, I think he's not here. I think he has some problem about the instrument. Like it has quite a bit 29 signals. In one of the PMF factors. I think his instrument, his top SSM is fast switching, like basically switch every 20 seconds from the filter mode to the sampling mode. So I suspect, I think it might be the 29 signal is so noisy is because of that. I haven't heard back from him yet about this issue. Have you guys, whoever has top SSN, know this issue? Like if you switching like every 20 seconds, did you see like a very noisy 29 signal? No? Yeah, maybe we can see what he can do after he presented. Yeah, I haven't heard back from him yet, but like that's my hypothesis why it's so noisy and why it's seeing like one single factor.
What happened if Axel just exclude the 29? What kind of results then he got?
Yeah, I'm not sure about that. I haven't asked him to try because I still think 29 is a quite important variable. So
it is, but then you have at least you can see if there's some other ions which is having some similar problem. If you just exclude first
yeah,
that.
Okay, I will ask him to do this maybe. But yeah. But don't you think it makes sense? Like it's because of the switching? I'm not sure. I mean, the rapid switching is also it's kind of default in the top SSM, but that's probably why he didn't change it.
Yeah, I think it's default, but still, I think it doesn't count maybe the first 2 or 3 seconds when it switches. I think it's excluded those first
No,
seconds.
it's not like that. So I think
It's not,
that's
our
not the
instrument is doing
default. So what they switch in is actually every 20 seconds they will switch.
Yeah, it's switches the valve, but it doesn't take into account the first few seconds in that 20 seconds period.
Oh, really? I
I
think
think at least
I don't
our
know.
instrument is doing that kind of thing.
Okay.
But of course, I'm not totally sure, because it has been a lot of different kind of issues. But
I
at least
think-
there's an option that you can say that do not take into account these first few seconds.
Mm-hmm. Yeah, that should be the case, but I think in my understanding, what is being done, like normally we don't use this fast switching. I think normally it's like first three, for example, 10-minute resolution. First 3 minutes is filter mode, and the rest is 7 minutes for this sampling mode. And within this 3 minutes filter mode, and because you do get a data point every 20 seconds, you just don't include the first few points for the filter mode, and for the sampling mode, you also don't include the first few points to minimize the switching effect. But I'm not sure if for each data point within this 20 seconds, they really do this. That's what I'm not sure about. But yeah, so anyway, let's see what he has progressed regarding this. He's not here apparently. And I think the Heisenberg, the Francesco took over, and he will present it. And I think they should be finished on time. Hutiala should be able to finish on time. And the Kustis, I think I had a few meetings with Petrol and Radek, and I think we need to dig in from my side for their seasonal solutions, summer and winter. And yeah, we should have some regular meetings, which is scheduled by I think next week. And for this data set in France, I think Veronica just recruited a new PhD. Hasna is here, and she will start to working on the rolling PMF. Just need I think it needs my support, and I will support her as much as I can. This might be a bit. I don't think it will be ready by this month, the results, but at least they have the seasonal solutions already. But maybe could take a couple of months then to have it. Will be delayed, but I think it should be manageable. For the mail pits, I think Samira just finished STSM visit at PSI last week. And we were trying to get out the CCO from the winter data. Should start to the final few runs for the few tests for the rolling results soon. I believe we should be able to make it for the deadline. And the Paris, I think I haven't heard the updates from last time. But I think the problem is here still need to have an agreement regarding how we differentiate the number of different number of factors, especially for the LV or LO and MO always. I think for this data set, Appling didn't have some. I didn't hear anything back from her yet. If there's not so much progress, I think it will be also considered to contact Francesco in order to catch up the deadline. And the North Kensington, I think I have the regular meeting with Anna, David together, and we're trying to get some decent seasonal solutions so far, and hopefully we'll be ready to run the rolling in a few weeks. And the Zeppelin is still in my hand. I haven't started yet. The Zurich maybe need to look into the seasonal results as well. Try to get the cigarette spectre if possible. So that's the status of those unfinished sites. So Andre, you're here, so maybe you can make some comments, I guess.
Do you hear me?
Yeah.
Okay. Sorry, guys. I thought the meeting was at 10. So it was the wrong schedule. We realized when I came in. Yeah, I don't know. I don't have much to say. I guess you did all what that was necessary to say at the beginning. So I'm not sure if it's necessary that I add something, but I'm happy to listen.
Okay.
I mean, how many are we? Do we have? You know a little bit about the schedule? How long we will spend today?
Sorry.
You know how long we will spend today? I mean taking into account who is.
Oh, the schedule.
Yeah.
Schedule is here. So I think probably we have quite a long lunch break. So. Yeah, we don't have many updates. But yeah. We'll finish it by 5, I think. Just a long lunch break. Yeah. Good.
Looks fine to me.
Okay. So maybe we start the next presentation, Olga. Right on time. Yeah, we can switch. Let me just open yours.
Hi everyone. I will show you my results from Raleigh, PMF for the Athens Dam Station. We just kind of finished it here in PSI. So our station in Athens, it's on the hillside of a mountain. It's surrounded by pine trees. It's close to a city's main road and 6 kilometers from the center of Athens. So it's considered a suburban background station. So we have a Duffy system and we have measurements from November 2017 to October 2018 with 10 minutes resolution. And we also have measurements from accelerometer AE33 from November 2017 to October 2018, and some NOx measurements only from January to July 2018. So for these runs, I used the Kribas HA for constraint, and I got my COA and BBOA for my winter runs. I used the random A value from 0 to 0.5 with a delta 0.1. I had bootstrap enabled. I used the 14-day window for the rolling and the 1-day shift, and I did 100 repeats. For the criteria list, I used the t-test for HIE fossil fuel black carbon, and also for BBOA with black carbon biomass burning and with variable with explained variation of variable 60. And I chose the p-value to be less than 0.05. For the cooking factor, I used the ratio of 12 to 9 and 10 hours. And the profiles have variable 44 for the LV and 43 for the SP. So this is the profile that I get. I get one secondary, which is less volatile. It has a rather stable daily plot. I also get a HOA. We can see here the morning and the evening peak in the rush hour. I get the biomass burning factor with the evening peak here. I also get the cooking factor with the noon and the evening peak. And then I have another secondary, the same volatiles, which has a diurnal that seems to be not flat through the day. These are the time series for my factors and the fractional contribution. We can see that the secondaries are the dominant factors for almost for all the year. And also we can see that the biomass burning factor is more dominant in the cold months and doesn't contribute much to the warm months. These are the pie chart plots for each season: November, winter, spring, summer, and September, October. So as we can see, the secondaries are more than 50% contributing for each season. And we have an HOA contribution from 6 to 12%. The BBA contribution is almost double for the cold months than the warm months. And also the cooking factor is almost steady as the HOA factor. These are the error estimations. So we have for the secondary, for LV, plus minus 70%, for the HA 27, for the BBA 21, for the COA 19, and 38 for the semi-volatiles. So the subtracted F44, F43 plots seem to be horizontal for the cold months. Also here in spring, these are the March and early April data points, which seem to follow the same horizontal line as in winter and November, while for the more warm months in May and late April, they follow the summer slope, which is more to the right of the triangle. And this is the overall subtracted F43 plot. So besides these rolling results, we also tried here to get a call factor because we saw that we had a 115 contribution in the winter mainly. So for these runs, I used the CRIPAS HOA and NGS DVOA for constraints. And this factor is seems to be the call factor. We see the 115, sorry, 91 and 77 variables. And for the winter runs, as you can see in the diurnal plots, so this is the diurnal plot that I get for the call factor for the winter runs, which seems reasonable to be in the evening. But the issue that we had was like that when we try to constrain for the spring and summer also, here I show you only spring, when we try to constrain with this call factor, we always get two peaks. They seem to follow the HOA daily plot, a morning and an evening peak, which I don't think makes sense for warm months. So we were wondering if anyone has faced something like this before and can help. So that's it. Thank you. If you have any suggestions.
Well, I would have maybe two questions. I mean, so the coal. I mean, are you aware of coal emissions in?
Sorry.
Are you aware of coal emissions in?
I know that we don't use.
No, this is Athens.
Yeah, I know that we don't use coal for heating.
They use coal. Yeah.
They don't.
But they don't.
Yeah.
But they use coal for something else. Then?
Maybe one thing that we thought was that it's maybe charcoal for grilling purposes.
Mm-hmm.
And also, I saw that the weekend's contribution is more for the coal factor, which makes sense. I mean, the restaurants grill more in the weekend, and it's also in the evening.
Okay.
Hi, Olga, can you hear me?
Yeah.
But in this case, I mean, I agree that if the coal is there, it is not from heating. So in that case, you shouldn't find the difference between the warm and the cold months. And the double peaks that you see, if they follow COA, it should be fine.
They follow more HOA than COA.
Okay. So it could be mixed, but again, I wouldn't expect the COA diurnal profile to be similar to BBOA. Should be different.
So one thing I think for her spring season, if you look into the diurnal 115 variable, it alone, it also appears to have a traffic like diurnals. They do have a rush hour peak for the 115 as well.
So early morning, right?
Yeah.
But also in winter?
No, in the winter, no. It's more pronounced in spring and also melts in the summer, but not in the winter.
Okay. Yeah, but then the interpretation of charcoal is a bit difficult. It's probably not much charcoal burning in the morning, I assume. Or I don't know. I don't know what kind of habits you have.
Yeah, it should be strange to be early morning. Though. I would expect it to start around maybe 11.
But only in spring?
I mean, for the restaurants or something.
Maybe you can see it in spring because you don't have biomass and it's less mixed.
Mm. Yeah, I mean the mass spectrum looks quite okay. I mean, at least in winter. I mean, it looks a little bit like I also would expect coal to look like. Here here it looks like this, but I don't know. You have to think about it more, or I don't know. It would be good to have a hypothesis, I guess. So where is the coal factor going when you have less factors? I mean, is it a significant contribution actually?
What's the contribution again for the coal factor?
I'm not sure. I think it's around 10%, but I will check it again.
But here you see, like for the winter, you have 0.2, like it's more than less like HOA, even higher sometimes in the evening. In the warm season, it's also quite a bit.
I mean, did you check what happens to the HOA versus BC traffic correlation, if you add the coal factor or not? I mean, does the correlation get better or worse?
No, I didn't.
Maybe I think that will be a good.
Yeah.
First, if you have like a
Yes. So you compare with
Yeah. So I would look a little bit at that maybe. I mean, for the BC wood burning, it could be that it should follow both. That's who knows. I have another question on the errors. Can you show the errors? Yeah, I mean that there are like two populations sometimes, or especially the HOA, one sees that. So I'm kind of wondering what these are different periods or I don't know. I will check a little bit because I mean it doesn't look like that it's totally consistent over time. So as if there's different periods where different things are happening. So I don't know. Maybe you wanna look into it.
What are those? What are those?
I mean, was the instrument in a different state, or is it just season, or I don't know. Yeah. Might be good to know.
Yeah, because normally this plot for the POA is primary is not quite interesting. Okay. Good. The next. We think we have coffee break, don't we? Yes. Yes.
Yep, very good.
or any other questions? Maybe for Olga, from Olga? Yeah, we still have some time though. Yeah, I thought it was 10:20, but it's 10:30. Yeah. Do you have other questions for Olga? Yeah, but I think
so. I have a question. Maybe if you do unconstrained PMF, do you also get something similar as this coal factor?
I get it for winter.
So I think for winter, he does get some like coal factor looks like coal like factors, but the 44 is not zero. 44 is zero for the coal. So that's why she tried to constrain the BBOA.
Okay.
Yeah. So that's, I think for the coal factors, in the winter, it will be easy to be mixed with the BBOA sometime, and if you go with like less mass to charge ratio, like what you did before, and when you go higher, it might be mixed with the HOA sometime as well. So,
I mean, as you have a bit time, I mean, can you show just the time series in winter of the two? Do you have that somewhere?
Yeah, with the coal factor.
Coal factor and biomass burning. I'm just curious how well correlated it is.
Yeah, I don't have it.
that would be worthwhile.
I mean, if it's correlated all the time, I mean, then I wouldn't believe that it's really. Then it's maybe just an issue with the constraint profile of NG that is not totally appropriate.
Yeah, but like I just find it's really tricky to understand why you know, in the warm season, spring and summer, 115 signal has like a traffic like panels, you know, like that's, I think it makes it impossible to interplay it as a whole factor. Difficult to separate it, at least.
I don't know. I mean, maybe the HOA in Athens is a bit different than in Paris. So maybe 115 should also be present a bit in the HOA. I don't know. I'm just maybe a different. I don't know.
You know, I think
I mean, we have never looked so much in detail in this 115, I believe. We have places where we didn't think there was coal, so I'm not sure how much we know or how well that is. I mean, does anybody else know where 115 usually go in their data sets? Which factor? Does somebody look at that? I don't know.
Sorry, can I ask something? Could this is Yasonas, by the way. Could the 115 fragment be attributed to heavy oil and not coal?
Maybe.
So, because I have some general comments about Athens, it would seem pretty odd to me to have a coal factor as you don't get any fossil coal use in Athens for heating purposes, and I can see here that the profiles always have an MZ60 in there, even in spring, and my thoughts. My thought would be, I don't know what's happening during summer, what's happening to the coal factor during summer. It still has a 16 there, an MZ60, which would mean that it's not fossil coal, but it is coal used, charcoal used for cooking. But I wouldn't expect the contribution of 60 to be that high during the summer months as well. So these are some of my general comments, but heavy oil could be attributed, if 115 can be related to heavy oil, to the port in Piraeus and to some general circulation. You could look into that as well, to sea breeze thing, I don't know, that could bring marine shipping emissions from ships at berth at the port of Piraeus to the site, and you can measure that.
Thanks, Walter. I will look at.
Or oil heat. I mean, there's also a lot of oil heating in.
There is a lot of oil heating. Yes, Andre, but it's diesel. It's not heavy oil.
Yeah, but I don't know. Maybe we should check the profile of in Ireland. No, I think there was that HOA was more. As far as I remember.
Heating oil.
There was the heating oil. Yeah, I mean, was that containing 115 as well, or not?
Because we only run PMF below MZ 100, so
okay.
150 is not good.
Yeah, I see. Okay. Yeah, I mean, the only other data set, I mean, we had you looked at the data set in, where was it? Lithuania, where there was in winter they, or I don't know when, which is, doesn't matter. I mean, they were turning on the kind of a heavy fuel oil power plant, something nearby, and then we had another factor. So maybe you can pick that up, what we found there, because we had kind of two factors that looked similar. I mean, kind of two HOAs or so. You could have a look if it was strong in 115.
Usually, I think
But I mean,
key paper where you have the coal factor, right? There you don't have 60, I remember, but how was it the HOA looks like for regarding that data set?
Do you mean MZ60? For coal burning, it doesn't have any signal at MZ60.
Yeah, but like, was that data set also affected by the oil?
we don't hear you, Ian, or I don't.
No, I mean, like,
You have to get closer.
yeah.
We don't hear you.
Yeah,
Sorry, I can't hear you well.
Sorry,
Yeah, we cannot.
what I meant, sorry, can you hear me now?
Yeah.
Yes.
Yeah, so I think in your that ESMT paper, you said that you have the coal conversion factor.
Yes.
I'm just wondering, in that data set, did you also have is that data set also affected by the oil heating there? If that's the case, then well, that HOA have some 115 in it somehow.
Yeah, we have source measurement of coal combustion, but for ambient source apportionment, we run PMF below MZ 100, so 150 is not included because we consider it's the signal to noise ratio is not good for higher. So I can't comment on that.
Thank you.
Sure.
Okay.
Yeah, I would check if it's really. I mean, if it's super highly correlated with biomass burning in winter, then I will not think it's separate.
Okay, good.
Thank you.
Then we have a coffee break then. And let's see, we come back at 11. Okay, see you guys later. Or you can join the coffee. Hello. Shall we continue?
Hi, I'm ready. I can share my screen.
Sure, yeah, go ahead.
Yep. You can see the presentation.
Yes.
Okay, so I will start or just waiting a little bit.
I think you should go ahead and you can start.
Sorry, I cannot hear you, Jan.
Oh, sorry. I think you can start.
Okay, perfect. So I'll present now the updates for Bucharest Mogurele Station. We are a GO station located in the Southeast Europe. Even if on the GO description we are pointed out like a regional station, from the in situ point of view, we are a peri-urban one. We are located here where are the red stars in Mogurele city, at 6 kilometers away from Bucharest, the capital city of Romania. In the lower image, you can see that we are nearby the ring road of Bucharest, so highly influenced by this. In this SOFI experiment, we used data from the ECSM from September 2016 to August 2017, but we also have additional measurements like black carbon and gas phase concentration and meteorological measurements. So for the settings, at the end we use the hydrocarbon organic aerosols factor to constrain a local one that we have it from the AMS data. And for the cooking, we use the CRIPA spectra, and for BBOA the NG spectra. We usually had random values from 0 to 0.4 with a step of 0.05. We had the bootstrap enabled, and for us worked the best with the 14 days window with 1 day shift for the rolling part. We had 100 repeats for each season, and to analyze, we used the t-test, and then we had the correlation for the traffic and BBOA with corresponding BC or with NOx. And then we had the PEV, we used the p-value 0.01. And we get it cooking on coal combustion factor, and for that we use the explained variation at MZ 150 as is in the last protocol. And for the cooking, unfortunately, we have different criteria for winter and summer, because it seems that the meal hours are a little bit different in that season, and of course sorting for more and less oxidized factors. These are the average profiles, factor profiles. So we have the traffic one, the BBOA, which are for the entire, for all the seasons, and then we have the coal combustion. We get this only for the winter time. We have the organic oxygenated aerosols for the winter part and for the spring, and then we have cooking for summer and winter, and less and more oxidized for autumn and summer. Here are the diurnal variation also for the lunch sorry, for the lunch time, we have only small peaks, but a little bit higher in the evening. The coal combustion, it's a little bit higher during the evening as expected. And then we have a flat diurnal for organic oxygenated aerosols and for more oxidized aerosols. These are the time series that that we have it in using this criteria and types of runs. And here are the fraction for each factor during each month. As you can see, during the summer and even during the autumn seasons, we have a lot of oxidized organic aerosols, like the higher proportion on this season. The coal combustion factor during the winter time is not so important, but it's around 10%. While the BBOA it's higher during winter and the spring. Here is the error estimation. I'm a little bit concerned for the cooking factor, which has 42% of errors. In my opinion, it's a little bit higher than expected. For the others, look quite reasonable from my point of view on the average solution. Here are the contribution season by season. We can see that we have above 50% of secondary, and it's not depending on the seasons. The higher percentage of secondaries are during the autumn season. And here are the factors and corresponding concentrations. As you can see, during winter, we encountered the higher concentration during this the analyzed year. Here are the subtracted information for F44 and F43. As you remember, for the spring and the winter time, we have only the BBOA and organic oxidized organic aerosols. But from my point of view, we quite reasonable these plots. But for the summer and the autumn, we have the less and more oxidized oxygenated organic aerosols. I have some issues regarding the results that that I have it up to now. So before I stick it with 4 factors during the springtime, but as you can see, when I plotted F44 versus F43, the less oxidized and more oxidized are in the lower part of the graph and seems not so nice. So I go back to the 3-factor solution, and in my opinion, it's the best. So this is from my side. If you have questions.
Hey Jenny, thank you for the presentation. Just wondering here in this plot, in this figure, can you hear me properly?
Sorry?
Can you hear me? Is it no? Okay. How about now? Is that better?
Sorry. Yeah, it's a little bit better. Sorry.
Okay. Can you share the screen again?
Yeah, sure. I thought that it's just me that I'm not hearing. Okay.
And for this last slide, the profile you show, I don't quite get it. I mean, you said it's 3 factors, but you have like 6.
Yeah, because it's the average solution for all the seasons. But
Okay.
when I took it for the spring, only the 3-factor solution in the left part and the 4-factor solution in the right part. So it's the average. You can see that for the less oxidized and more oxidized, actually it's looking better with the 4-factor solution for this when we took it the 4-factor solution for the springtime. But when we subtract for F44 and F43, it looks much better with 3-factor solution. And actually, in my opinion, this is the best. It's just
So 3 factor is here you differentiate 1 and 2 OAs, is it?
yes.
Yeah.
It's only one OA, and in the other part are 2 OAs.
But why you have like two like squares, let's say, in the left?
I took it the BBOA and the OA on the subtracted part.
Okay.
This is the reason.
But I also don't understand. I mean, in the right hand side, I mean, there you have a LOA and MOA, right?
It's LOA and MOA.
Right. They have, but they have nearly equal amount of 43 and 44. If I look at the mass spectrum.
Yes.
Right.
Yes.
But then what you depict here, I mean, is much less 43 than 44.
Yes. But this is when I averaged.
So why is that? Is there so much 44 in the residual or something? Because I mean, the only thing that is in there besides LOA and MOA is in the residual, and otherwise you cannot explain this graph.
Yeah, should be. It's just
Maybe you
for
have to
me.
check if this is calculated right. Somehow I don't believe this.
Yeah, me neither. This is why I ask your opinion.
Yeah. Also in summer, I mean, usually you expect it to be on the right hand side. So
yeah,
I don't know. I think you should.
Did you add the BBOA here?
Yes, I had the BBOA for both of them. Yeah.
So for I think for the spring, I won't do like that. I mean, for the winter, you might have some mixing between the BBO and your LO.
So subtract it, not putting the BBOA, only the secondary.
Yes.
Okay, I will have a look on this way too.
So all your 44, 43 plot, you include the BBOA, is it?
Yes.
Okay.
Aha. Sorry.
I think
this plot includes BBOA.
Yeah.
Yes.
So
that shouldn't matter.
Sorry?
That still doesn't explain. That's just where is all the 43? I mean, in BBOA, LOA, and MOOA, there's a lot of 43. So I don't know, where is your 43 going? I think there's something wrongly calculated.
Okay, I'll have a look.
It's not from that season over there.
Okay.
It doesn't correspond to this graph above, unless you have tons of stuff in the residual.
So Jenny, I think one thing is here, you said the profile you show right here is the average, yearly average, is it?
Yes, it's the average, yeah.
So, I mean,
here is a
Okay.
yearly average. It's not just for this season. You know what I mean?
I see. Yeah,
Yeah.
okay, then it could be.
So when you do like this, if you want to show this, maybe you do like you know how to show like time dependent profiles in the SOFI?
Yeah, I can select only that month that I wanted. Yeah, sure.
Yeah. Maybe you should look into the example 3-factor spring, look into the SV and LV, how it looks like.
Okay.
Then you can, you know, just for the spring.
Yeah. Okay.
Yeah.
Yeah, maybe also summer. I mean, it just seems like you have very little 43, which is a bit surprising in the warm season. In the OAs.
Yeah. Okay. Thanks.
I mean, otherwise we in this case we have strong change in number over the seasons of factors, right? So
yeah.
So that would be I don't know. I mean, the strategy how to run this in a rolling mode. I'm not even sure.
I think
is rolling.
For different
this is rolling
and combine it.
Yes, is rolling, and I combine it at the end.
Okay.
Yeah, I mean, this is a question also. I guess the Paris data set Laila faced. Do you guys agree that we set the number of factors based on the seasonal solutions?
Yes.
I mean, I think that's I don't know. I mean, I feel like Francesco Jay don't like it. I'm not sure. What's your opinion, Andre?
Say it again.
Sorry?
Say it again.
Yeah, so for example, if we define the number of factors based on the seasonal solutions, let's say in the spring season, you only have one OOA, but in the summer, you have two OOAs. And then you only run one OOA factor for rolling for the spring.
No, actually, I didn't do like this. I had only OOA, but I ran it with one OOA, but also with two OOA, and had another look for the rolling.
Yes, I mean, but like when you in the end, when you decide how many factors, you still select one OOA just for the spring, example, or for the winter. Is it?
Yes. Yes,
So
because they are looking better, let's say.
I mean, that's basically my question. I was saying, does everyone agree? Like we define the number of factors, maybe. I mean, you can look into the rolling results as well, but when we set the boundary, like the transition period, we define it based on the season. Like also, yeah, I mean that's a question.
Yeah, that's true. It doesn't need to be always like this.
Yeah.
I mean, like you can. There's many things because different places you can say, oh, you can do it based on the temperature. You can define the season by temperature. You can define the season by many things, but also by just the time. Let's say so. Now we are doing it based on the time, but does everyone agree to have this differentiation based on the seasonal solutions, and we define this period like based on the time?
I agree with this.
Yeah.
Sorry.
I understand your concern, like from my experience in Ireland, for the standard PMF, I cannot find the second way because the missing MZ43 or something. But if we're using the rolling PMF and use the criteria of not selecting MZ43 being 0, 1, being 0, 44 being 0, I can find 208.
Yeah. It's the same for me for the autumn part, yes.
Yeah.
Just like this, on seasonal solution, I have only one OA, but then when I'm triangle rolling, I can get two and looks nice.
Yeah, I mean, maybe one can make it still dependent on, for example, also external correlations or something, or other criteria why one chooses them a different number than in the seasonal solution. I mean, that's maybe still fine, yeah, but for sure, I mean, to find maybe a different date, for example, where you change, I'm not sure. I mean, that maybe that's maybe more for individual data sets, but not for, you want to do it in a kind of similar way. But I mean, what I understand now, it's, if it's less factors, we still try both with the rolling, right? But we don't change the dates from when we test the, I mean, if then, for example, a 4 or a 3 factor solution is better.
Sorry, Andre. So I experienced something like this. So for the May, I can have 2 OA for April and even for March, but then on May I have 2 or 3 weeks that it's somehow strange. I can get it only 1 OA when I look it only for the spring week by week.
What is the criteria there? Why are you saying that?
We have the criteria. So we have the EC traffic, and then the correlation goes to 0 or near 0 for those 2 weeks. But for the others, it works perfectly. So we have nice correlation. But for NOx, we have nice correlation even for those weeks also. So I use it both, the BC traffic and the NOxes for the criteria based on HOA. So I know.
Yeah, I guess that's a good approach. I mean,
but this is
if
only
the
for.
correlations are clear, if the correlations external data is clearly better.
Yeah. Yeah, but this is happened in Bucharest case only for the May.
Yeah.
For the others, it works perfectly with both, with NOxes and BC traffic.
Yeah, but like in general, I think, because I mean, even in the seasonal, as Trenshu just mentioned, like in the seasonal conventional PMF, normally it's difficult to get the 2 OOAs, but like if I mean, if it's possible and if it makes sense, I will really push it into 2 OOAs in the rolling. If it makes sense. Only, I mean, then you will like minimize a lot of troubles regarding the differentiate. So if you really can push it to the same number of factors throughout the whole year, I will try that.
Okay.
If it basically gives the same result or something,
yeah,
then maybe it's better to use 2 factors throughout, and you don't have any kind of at some point a change. I agree.
Yeah. Also, one thing you could try is, because now the SOFI have the combined factor functions. So you can also see if the combined factor regarding the time series those things, are they similar to when you only have one factor, one OOA factor, for example. So when you combine them, you look into the factors, factor profiles, time series to see if they are actually, if it could be, you know, somehow combined, it's the same, then it doesn't matter. You can just, you know, run two OOAs, then you combine it later, and to see where you can actually use this combined factor instead.
Okay.
Okay, sounds good.
Okay, thanks.
Thank you. Yeah, let's go move to the next. I think Marta, yeah. Hello.
Okay, let me. Can you see it properly? Right?
Yes.
Yes, yes.
Okay, so I'm Marta Villa. I present my most recent results on the source apportionment in Barcelona with the rolling results. Sorry, why is it not working? Okay. As a quick backup, our station is located. Our site is located in Barcelona, in the northeast of Barcelona, and it's a urban background site. And this campaign lasted from September 2017 to October 2018. And gas phase, black carbon, PM1, and meteorological measurements were available. And as settings for the input matrices, we applied the Middlebrooke correction, but not the Peabody effect correction. And the down weight of CO2 related ions was performed in SOFI. And we also down weighted the weak or bad as an signal to noise ratio ions. So the settings for the SOFI itself were these ones. HOA and COA were anchored with CRIPA's anchors, and BPOA was anchored with the profile from the seasonal analysis, and the ranges of phase values were from 0 to 0.2 in case of the COA HOA, and 0 to 0.3 for the BPOA. In all cases, the step was 0.1. The bootstrap was enabled, and the rolling was enabled too, and with a 14-day window, with 36 repeats per window. And a few months ago, I also tried 28 and I think 7-day windows, and the best results were given with this configuration. And from the seasonal, we know that BBOA only pops up during the colder seasons, from November to March. The major novelty of this presentation is that we tried to test the goodness of t-test versus bootstrap selections with same given criteria. These are the criteria, and the seasonal thresholds consist of the percentile 10 of the seasonal bootstrap. And in the t-test selection, we used the lunch peak over 1 criteria for COA, correlation with BC for HOA that showed a value of showed a p-value over 0.05 in the t-test, and for the oxidized OAs, we selected the 44 as a criteria for more oxidized, which was used for sorting, and the 43 just for monitoring. And finally, for the 4-5 solution alternation, we used explained variation of 60 and selected p-value over 0.05. Okay. These are the mean profiles, the period average profiles of this data set. We've got the typical markers for COA, HOA, BBOA, and two well-differentiated OOAs. And these are the dials. We see the typical peaks of traffic, cooking, BBOA factors, and we see this valley, which has also been found in the seasonal solution. And these are the time series. As you can see, BBOA only pops up in winter, well, in this extended winter from November to March. Although we have these remaining points before and afterwards this period used in the seasonal, which I will be talking about it later. And if we take a look at the pie plots, we see how more oxidized is the major source here, followed by the less oxidized. And the proportion of SOA over OA varies through the year, being maximum in summer, and also a proportion of POA. This is the seasonal or monthly cycle in absolute and relative concentrations. We neglected the August because we had really few data there. And as a trend, we can see how HOA decreases in summer months, how BBOA only happens to appear in the coldest seasons. And we also observe how in winter we get the more oxidized OOA, as the ratio is higher in winter months. So we expect to have a fresher OA in winter, in summer or in warm periods. Okay, as I said, we got a quite good differentiation between both profiles. And if we take a look at this model subtraction for more and less oxidized OOA, the first in squares and the second in round, we can see how they are quite differentiated in all the seasons, with best differentiation in summer and worse in winter, and how the 44 does not make a change, a very high change between along the seasons. It stays quite flat. For example, in this summer is quite visible, although the 43 does move along the season. Maybe this indicating that at certain hours of the day there's this triggering of SOA production or some issue I have to look on more deeply. And if this might be related with these other plots in which we see the higher error for more and less oxidized OOA, as the others, the POA stays more constant and, well, more constant, I mean, the spread is lower for these three factors than these others. And here's the other issue I wanted to talk about. I really don't think these edges should be appearing as from my seasonal solution. I know this BBOA had to stop, well, had to start and stop from November to March. And I don't think these extra days here before and afterwards are really, I don't know how to call it, but I don't think they should be there because they don't respond to a selection I did. I want this BBOA to appear just in this range of months, and this is unwanted. So I got rid of it, and I managed to select plus or less 7 days to remove them. Although I think I missed some runs here, maybe due to availability data problems, or maybe because a selection didn't cover these points. It's a thing I'm working on, and I will be presenting this, well, not presenting, but I will be tackling in the first meetings or so. And here's the comparison I was talking about. I compared the t-test selection versus the bootstrap selection, and also between this sharp edges solutions selection in both cases, and I saw that the selected runs did decrease from t-test selection to bootstrap selection, although the missing time points are not significant, are basically the same. The t-test selection of sharp edges did differ from the t-test selection. Obviously, I am losing a few points, but I don't think an 1.77% is that worrying. And if we take a look at the correlation with externals, in any of the cases, there are different, significantly different figures. Neither there are in the scale residuals, as in all the cases, they are sharply around 0. So as a conclusions, we get in Barcelona 5 sources: COA, HOA, less oxidized, more oxidized, and BBOA. The major source is the more oxidized OOA, followed by the second OOA. We see how SOA is enhanced in warmer periods and how the proportion between less oxidized and more oxidized varies throughout the year. And we see from this comparison that selected runs in the t-test are higher than in the bootstrap selection, and that runs adjusting these 4-5 edges solution do not differ much in terms of correlation with externals. And that's the last one refers to a thing I've already said, like that the test selection saving more data, even though not compromising the quality of this data. So that's it. Thank you for your attention.
Thank you, Marta. So you were saying you don't like the BBOA in the May. Why is that? I mean, why?
Sorry. On the April.
April, yeah, sorry. Because based on the seasonal solution, that's what you said, right?
Yes, because my decision of taking the BBOA solution.
Well, like,
it was
for
based on.
example, let's say if you just run a PMF for April 1st to April 7th, 7 days. Well, does it make sense to have BBOA there? If that could be justified, I don't think it's a problem, you know.
But I made the decision on it being in this month or not based on the F60, which was not relevant on this month. So I don't think it shouldn't, it should accidentally appear, because that's not willingly that it appears.
Yeah, I mean, that's because here you have 14-day window. I mean, I think the Sophie is trying to average, give more weight to the more number of factors. That's why you have this, but yeah, but like as long as you can justify or saying, I mean, it's not so much different, even though you only select plus minus 7 days, but just compromising some of the missing days. But I don't think it's a problem, but I personally, I don't think it's necessary. That's what I mean. I mean, I feel it's still okay, even though you have some BBOA in April. Because, you know, first of all, the concentration is really low. And it just, I mean, that's the rolling results. So in the rolling PMF, on some time, you do, because in your seasonal solution, you do not see anything maybe after April, but like in the rolling, you might still have some. And for example, in the beginning of November, the end of October, it's quite a bit. So I still believe those are true.
But
Yeah.
You know, in Spain, the spring starts earlier, so it could well be. But I mean, these few points or few days in March. I mean, do you think that there the F6 is the F60 there, or would it make sense to remove those as well? You know,
we have little data in March, but still revealed an F60 above the threshold.
Okay. I mean, just these last points after this break.
Yeah.
I don't know.
Yeah, also need to be careful about if you cannot solely decide whether or not you have a BBOA based on that threshold, because that threshold could be instrument dependent. So it could be a reference, but it cannot be only one. It cannot just decide based on that.
Yeah, but sorry, if I didn't misunderstand, the period is also, let's say, artificially defined. Like the user defines when you have certain number of factors or the other number of factors, which means you're gonna put the edges where you want. Like in this case, you set this criteria and then you do this other selection for the sharp edges. But if you define from the beginning 1 month before and 1 month later, then that would be also a user-defined solution. It's not that you give the freedom to the model to give you BBOA all year long. So then in the end, it's a matter on which criteria you use to say till here. If I didn't misunderstand, because
yeah. No, I think I also would look if there's no structure in F60, for example, or basically no structure and very low. I mean, then one could also skip it, but maybe it's those last days there in just before end of March. Maybe if you don't have much 60 there, then I would rather take those away as well. I mean, then just to say, okay, your season in Spain obviously is winter seasons anyway.
Yeah, but I don't remember now exactly the plot, but I'm sure we looked at that like quite a few times before deciding if because it also bothers us like to have this gap and then only these few data in the end of March, but and also like somehow we didn't want to force only because we think that in Spain no one uses a fireplace in March. That doesn't mean that it's this way if data say otherwise. So we didn't want to force, to have this I don't know the word.
Yeah, the main results are even not changed. I mean, I think the only thing I think this all looks very good. I'm a little bit worried about the F44, F43 plot. Can you go back there?
Yeah, that as well. Why it's so horizontal? That's my.
Yeah, it looks weird. I mean,
not that horizontal. You can see some movement actually, although not comparable to the 43 one.
Yeah, but why is the 44 always the same?
I think of it like a background 44, maybe.
What the background 43 as well? I don't know.
Yeah, but maybe it's more susceptible to. No, I don't know, but could be more susceptible to ambient.
So the threshold you use for this is you take all, right?
Yeah.
Yeah, I don't.
How did you sort?
F44 for the more oxidized and F43 for the less.
Wait a minute.
I've never seen this before, like so horizontal. Yeah. I mean, did you try to use that function like the slider to move around?
I haven't yet.
Which version is this again? You used to plot this?
The latest, I'd say.
6.D4 or
Yeah.
8? Okay. Yeah, I think it's strange as well. I think it might be worthwhile to ask Francesco. Yeah.
Okay.
If you,
Because sorry?
I don't understand when you sort by F44 and by F43. What happens then if you sort both? Didn't we say last time we should only sort
Yeah, so
by 44 and then finish?
although I monitored 43.
Ah, you monitored. Okay.
You didn't sort it.
Sorting was only done by 44. Okay.
Yeah.
I mean, I would expect, much more points going, sitting along the line of the points in between.
Yeah.
I mean, kind of.
Is this plot much more different at other sites?
Yeah, well, it never looks so horizontal. I mean, it's.
I've never seen this much.
Something is totally weird.
It could be just a Sophie problem.
Yeah, I kind of not believe that. And I mean, on the top that it goes so far to the right. I mean, why should it go so far to the right? I mean, something.
Yeah, that's as well.
That can actually not be. I think something is wrong. I don't believe this actually.
So for example, if you look into the.
We can check if the solution is really like this. I mean, so much 43. I mean, with 0.5 in F43, I don't believe that you have that.
Yeah, also 0.5.
Yeah, that's super high, till 0.45.
Something is like it's plotting wrongly. I don't know how that can happen.
Mata, could you maybe try to use another version of the Sophie and plot this again to see if it's Sophie problem?
Okay.
Yeah, I think it might be Sophie problem, not your solutions.
Okay.
Yeah. All right. So
Can we confirm that other people using the same version had the same problem, just to, or maybe we see it during the day today if we see more of these plots?
Yeah. I think most of people will show this plot. Yeah, let's see.
And sorry. So for next talk, if you have a moment, just please double check which is the version you're using before you get to your talk with this plot. So then we have that information also by the end of the day.
Okay. So here, Mata is 6.D4, right?
Yeah, let me check. Yes, I think.
Okay.
Sorry. Yeah, 60.
Okay, good. All right, so let's move on to Hans. Hans, can you share your screen, please? Oh, Hans is not here. Oh, yeah, you are here. We cannot hear you, Hans. Now, yeah.
Is it better now?
Yes.
Okay. Okay, so I will present the results for Tartu. Just to remind you, this station is urban station situated in a residential area, some kilometers away from the city center, but major roads are nearby. And what is important, that wood combustion stoves are widely used for heating there. There have been slight modifications in the setup. I'm still using Kripa's HOA and my own BBOA profiles as reference profiles. Also 14-day window with 1-day shift is applied in Rollink with 50 repeats per window. But I have let A values more loose, and now values up to 0.4 are used. On the other hand, criteria list consists of several changes as suggested by the new protocol. Most notably, the OA factors are now differentiated by using only F44. Since the less oxidized OA contains quite high fraction of MZ60, I'm also monitoring F60 and both OA factors. Here you can see the factor profiles on left and diurnals on right. Through the whole study period, 4 factors are detected: HOA, BBOA, more oxidized OA, and less oxidized OA with increased contribution of F60 during autumn, winter, and spring. Therefore, I have named it as aged BBOA. And 2 last profiles represent the combination of factors, namely sum of LV OA and aged OA, aged BBOA, as well as some of fresh BBOA and aged BBOA. The diurnal cycles of different factors are really similar with highest concentrations during late evening, around 8 or 9 p.m. in local time. And this is also true for HOA. If we would zoom into the uppermost subplot, we would see the morning rush hour peak at 8 or 9 a.m. in local time. Its concentration starts to increase again during the afternoon, but it continues to increase for several hours before it reaches a peak. And during weekends, the HOA is completely missing the first peak, and the second peak is seen a few hours earlier. On this slide, time series and monthly contributions of each factor is presented. As you can see, the measurements were ended in July. Actually, in the first half of July. So we don't have data for August. The contributions of HOA and more oxidized OA stay about the same throughout the year. While the other 2 factors, BBOA and aged BBOA, or let's say just less oxidized OA during summer, have strong seasonal dependency. The most notable change in BBOA concentrations appear in May, when its contribution is about half of its contribution in April. This is, of course, expected as air temperature increases and wood combustion used for heating decreases considerably. And the 4th factor has its biggest contribution during summer, when F60 in this factor is almost non-existent, as you will later see. This means we cannot actually call this factor aged BBOA during the warm season, in my opinion. Here you see some error estimates related to bootstrap and A values used. The relative error ranges from 7% for BBOA up to 46% for my 4th factor. As mentioned before, the HOA doesn't change much during the year. However, the wintertime contribution of BBOA is twice as high as during summer. Sorry, this is summer, this is winter. But even then, even during summer, its contribution is still higher than in case of HOA. And the percentages are 20 and 14 respectively. The absolute concentration of organic aerosol reaches more than 5 micrograms per cubic meter during March, which is not much, of course, if compared to some other polluted regions in Europe or worldwide, but it is still remarkable for a station in Estonia, especially because of quite high contribution of BBOA. Overall, my two OA factors are quite well separated in the F44, F43 space. The plot on right represents all estimates for the whole study period, and the other 4 plots are given for each season. And of course, the primary organic aerosol contribution of F44, F43 has been removed. I have to say, I'm now using SOFI Pro version 6.D8, but I guess these plots were done using SOFI 6.D, if I remember correctly. On this slide, F60, F44 plots are presented, but I have included contributions from 3 factors. BBOA, on this plot, BBOA is here. LBO, or let's say more oxidized OA, and aged BBOA here. Usually aged BBOA derived F60 is higher than its more oxidized OA counterpart. But what is interesting is that occasionally the contribution of F60 coming from more oxidized OA can be even higher than in case of aged BBOA. For example, this can be seen during the last week of November. If you look at the purple points here and here. And in the beginning of December. For seeing this in December, we should look at the red points here, which are not nicely seen, but still something is seen. By taking into account the relatively high contribution of BBOA, I believe, and I have also discussed it with Ian, it should be quite reasonable that we see biomass burning somehow affecting even more oxidized OA. I have taken two-week study periods and put the profiles of more oxidized OA and aged BBOA on this slide. The plots on left represent the profiles derived from the data collected in the beginning of September, while the other 2 represent the situation in December. It is clearly seen that F60 in aged BBOA during September exceeded exceeds the F60 in more oxidized OA. But in the December, the situation is opposite. But these are quite short periods when this is seen. Okay, I will stop here and thank you for your attention. And I'm happy to answer any questions you might have.
Thank you, Hans. So have you, I think it's not okay to say this is HBBOA in summer.
Yeah, of course.
So I'm not sure, maybe, so I will still say it as a maybe less oxidized OA, but affected by the biomass burning. You know what I mean?
agree. I agree. I would say then.
Do you mean only summer?
No, for the whole, for everything.
Oh, okay. Okay.
Yeah, I agree. I would call it more oxidized, less oxidized, and then in winter for the winter in the text you mentioned that this is probably mostly HBBA because of the mass fraction 60.
Yeah.
I mean, to look at this, maybe, I mean, you took two examples. I mean, you could also plot the F60 as a function of season or a function of time of this less oxidized OA, just to see what the variability is in summer versus autumn, spring, and winter.
Okay, but what is your suggestion regarding, for example, spring? If we look at these red and orange points, is it actually aged BBOA or something else?
It could likely be. I mean, I would say, yeah, in the months from autumn to spring.
Yeah.
Quite a significant fraction maybe is aged biomass burnings. But
yeah.
I would plot it as maybe as a function of time. I mean the F60 in those factors. Maybe you could also plot the one from BBOA.
Yes, actually I have plotted these plots and we have looked these plots through the with Ian also.
Okay. Yeah.
If I remember correctly, yes. And yes, these are quite short periods when F60 in more oxidized OA is higher than in my fourth factor. So yeah, I agree. Yeah,
this can happen. I mean, this.
Yeah, but I agree. Calling aged BBOA during autumn, winter, and spring. Yes.
Yeah, but I still would call it less oxidized OA everywhere. But I think in the text you can say that for this site we interpret to be that it's influenced by biomass burning in the colder season from autumn to spring.
Okay, but I have also one question. What is the let's say estimated lifetime of BBOA before it oxidizes and give us aged BBOA, for example, in spring? And similarly, how long it takes aged BBOA to oxidize even further, so it eventually can't be called aged BBOA anymore.
Yeah, okay. I wouldn't call it actually BBA at all because I mean the SV or the less oxidized OA. I mean, for example, also when you put wood burning into a chamber and then you oxidize it.
Yeah.
You actually also often have F60 in the SOA fraction. So that means in winter, I mean, it's hard to distinguish maybe a little bit aged BBOA from actually secondary OA coming from biomass burning emissions. So I would just say it's biomass burning related. I mean, you don't know if it's aged primary or if it's secondary, but it certainly is influenced by biomass burning.
Okay.
That's how I would see it.
Yeah, I think Hans, one thing you could do if you have some ozone loss and the radiation, those data, then you can try to compare those points, like when you have when you're 60, it's higher in your MO than the LO, and compare those data with some when the 60 is higher in the LO than MO, and together with those ozone radiation, whatever, those data, you see if those, because let's say I will expect maybe when the ozone is higher, then you will oxidize faster, then you will have more proportion to the MO. So that could be one interpolation, possible interpolation for the changing of this. Yeah, but I will just call those L and MO still, but just for some of time periods, you just mention in the text how those are affected by the biomass burning.
Okay.
Yeah, I mean that so much F60 in the MOA is a bit strange. I mean, it could also be that there's some mixing. Maybe it's just regional. I mean, then you have more oxidized, but maybe you have also some regional biomass burning in the same air masses, and it just goes into the same factors. I mean, it's not usual to have a lot of F60 in the more oxidized OA, but I don't know. If it's short periods, I wouldn't worry that much about it.
Yeah, I think it's not so it's not common in his data set, but like just few time periods. So I mean, you can, if you want to interpret this, then you can do like what I have said.
Interesting.
I think. Yeah, I think I have asked Hans to sort based on the 44 only. I was also trying to see if the 60 and 44 are anti-correlated, but apparently still same result. So so we cannot do anything about it regarding this. So have to find out a way to explain this though.
Yeah, but just to be clear, these time periods when F60 is high in my less oxidized OA are not so short. These are actually quite long periods, like months, I would say.
Yeah, in the less oxidized, it's fine. There the SOA from, as I said, SOA from biomass burning contains F60, so that's fine. I mean, it's just if you have it in the more oxidized, that's a bit more unusual.
Okay, yeah, I understand.
Okay, good. Then we have a lunch break then. Come back at 2. Okay. See you guys later then. Yeah.
See you.
See you later.
Hello.
Hi.
Hello.
Hi again.
Hi, guys.
Hi, guys. So shall we start? Laila, you ready?
Hello, yes, I'm ready. I hope you can hear me well.
Yes.
Okay, I'm just. Okay, so good afternoon, everyone. I will present the results in the Paris region. Station to the Paris Metro, and we have had ACSM measurements since 2011, and this study focuses, for the study we take the data set from so I have to do it again because I want to follow the program very well, and I didn't do before the test of the day window, so I did it like in the last 2 weeks. It took me a while to do everything because I also had some problems with the software. So what I want to say with this results.
Laila, sorry to interrupt, but your voice seems to be a bit like the connection is not so good. Am I the only one?
No, I'm hearing the same with a lot of interruption.
Yeah, can you try to maybe have a better connection with your internet? Or maybe try the Ethernet.
Okay, I hope it is better now.
Again?
Yeah, so I don't know where you lost me, but for me I have a lot of noise. I don't know if from where it comes. Never mind. So yeah, I was saying that I was redoing the test of the window shift, and anyway, so the SOFI version that I'm using is the 6.d4. I constrained the HOA and BBOA profiles with CRIPAS and using a value from 0 to 0.5 for HOA and 0 to 0.8 for BBOA, and without using the bootstrap, and yeah, 28-day window shifts and 50 window and 50 repeats. And then the criteria used for HOA, I looked at the correlation with BCFF. For BBOA, the explain variable of M60, and for the both OAs, the separation with F44 and F43, and so, yeah, so not taking the zero solutions and also the sorting criterion. And yeah, and as I was saying, the thing is that I had to treat the data like yesterday because it took me a while to redo the whole tests with the different windows. And I realized that with the 4 factors that's always how I was doing it, using 4 factors, because that's how we had in the seasonal solution. Both a factor 3 and factor 4 seem like to look very, very similar. And so for the rest of the presentation, I used just the sum of both to just have one OOA factor
but I don't know. I have to do it again, I guess, because it didn't work well. I don't know where I did wrong, so I have to look at it. And so anyway, here as I said, I summed both OOA profiles and I show you HOA, BBOA, and OOA, as well as their diagonal variations. And yeah, so we have, I think HOA and BBOA are still quite clear. They look the same as when I did the test before. It's just that maybe BBOA was a bit also mixed with OOA again, so still complicated for this. And for the time series, here the same. We can see clearly for the monthly variation that here in the winter of 2016-2017, the BBOA contributes larger than for the other month. And also I tried to do the error estimation and it worked for HOA, but when I tried for the other factors, I got this error, so I couldn't go further and I don't know what happened. So I could only calculate it for HOA and I got 18%. And okay, and then for the contributions, here for the different seasons and over the whole year. Well, we can see that overall OOA is always the main factor, and just in the winter the primary factors are have a higher contribution than the other seasons. And finally, I also tried to do the F44 versus F43, and same, I guess I didn't do it very, I mean, I didn't try it before and now I just tried it today, and I don't get the same like plots as you, so I don't know if I did it also wrong. I have to check again with the protocol, but I tried to do it, and yes, and here's what I got for the factor 4 in spring and for the whole year. So yeah, thanks for your attention.
Thank you, Lela. Could you maybe go to your very first slide for your why is the bootstrap is disabled?
Why it is disabled?
Yeah.
I mean, also the other times I didn't do with the bootstraps. With Jean, we talked about it and we wanted to try first without. And since I'm not really, I don't really know how to use it, but I guess it would be better now that I had the first.
I think you guys already have some seasonal solutions.
Yes, we do.
So for example, here, what's the step of your of your A value again?
0.1.
Okay. So let's say you have like 6 possibilities for HOA and 9 possibilities for BBOA, then it's 54 possibilities. Then 50 repeats might not be sufficient, but I'm not sure why you need this high 0.8 A value for BBOA.
Because because of the fact that in summer we don't see it very well if we constrain it too much. We were afraid that it was not going to be good, so we didn't want to constrain it too much.
Okay, but like at least the number of repeats should cover all the possibilities.
Okay. Yes.
So that's one thing, and then, well, if I start to do the rolling, I'll enable the bootstrap. You want like it will not slow down your process. So I don't see why you don't use it for the bootstrap. And another thing is just to make sure here while you're sorting, did you sort it based on 44 from the MO, or you use the ratio here? I see the slash right there, and just to be correct, just to be clear.
Yes, I used with, I mean, one of the factors with F44 and the other one with F44.
Okay, good. But do you also have the other external data?
Because I mean, before I was using also the same sorting criteria for, and I had both. It's worked well for to separate both OA. So I don't know why this time it didn't work. And yeah, and for the external data, I have just BC.
Okay.
And the profiles.
Yeah, so I will enable the bootstrap.
Okay, the second.
And also the time window, that's your first trial, right? Of rolling PMF?
For the time window, I tried 7, 14, and 28, and that's where I got the more modeled points.
Okay. So, so to answer one of your questions while you're doing the scatter plot for the yes, I mean this one it has been fixed by the 6.8 6.D8.
Ah, okay, great. Okay, sorry, great. Okay, so and the 6.D8 is available on the website, I think.
It's in the share folder already, so
okay,
download it. Another thing is because here you did not enable the bootstrap, so maybe here is not your your arrow might be smaller. You know what I mean? So,
that if I use the bootstrap, it would become higher, or it would become
might be, not sure. It's
okay.
Because in the bootstrap you randomly choose something. So, but like here you didn't enable it, but like I mean, for the rolling, it might still make sense to have this, but if you do the seasonal runs, you don't have the bootstrap, then it doesn't make sense to have this arrow estimation anymore. The bootstrap, the arrow estimation will include two things in the rolling PMF. One thing is the variabilities of selected runs within this time point, at this time point. The other thing is because also you do the bootstrap for the data point, then you are also including this to test how stable is your solution. So if you don't use bootstrap, you miss something. You know what I mean? So here is just one part of the variabilities you included. And for another, I think your slide 10.
Yes, sorry.
The slide 10.
Yeah, sorry.
So here, I think the problem is why it's not as you expected is because here you used absolute. So this plot supposed to be the fraction. You know what I mean? Y-axis and x-axis is not fraction, it's microgram per kilometer.
Ah, okay, sorry. Okay, it's supposed to be fraction.
Yes. I mean, you can color code by those clouds by OA concentration.
but yeah. So, but like this space should be, this plot should be 44-43 ratio, not the mass concentration. That's why I think it looks not as we expected.
Yeah, it seems like the y-axis is, I think, absolute and x-axis is fraction. Maybe that happened.
Because when I just selected the model thing, and then it selects right the F43 and F44.
Yeah. No, I mean there's a button down there if there's absolute or a fraction. So you choose
okay.
fraction,
Got it.
and you go get the plot you want. I mean, it's still okay to color code those points by OA methods, but here I think you didn't include where the your PMF, I mean your OOA factors are. It's not included in this plot. It's just the clouds of the measured points of 44 and 43. So you should also include that. Anyway, I think we should, I think we should really schedule a meeting, regular meeting, like maybe once in 2 weeks. In 2 weeks, then to see if, I mean, also if you have any questions, like for example, that scatter plot sort of thing, you should contact me right away. Then I can, tell you what's the problem and how to solve those problems. This way will be more efficient. You won't stuck on one thing for a long time. So yeah, I guess yeah, just send me an email and we can schedule a meeting.
Okay.
And maybe you can also, I mean, you can also, you and Hasna, I think you guys can do it together, I guess, meeting. Then we can have like, because I think Olivia is also in charge of supervise Hasna, right? So maybe you two could communicate. Yeah, you guys could communicate a bit, and what we could do, we three at least, or some of your supervisors join the meeting regularly. Then we can do this much faster in the future. Okay.
Okay.
Yeah. Thank you very much. Anyone else have the comments, questions? Oh, by the way, why don't you have the cooking in Paris?
The cooking factor?
Yeah.
Because in the seasonal solution at the end, we didn't have it.
Okay.
I mean, there isn't. And it didn't come out well when Yoongjong tried it for the seasonal solution. So.
Okay.
It's mostly because Olivier likes it less than I do. I mean, I think the solutions are similarly good with the cooking or not in Sirta. It's hard to judge.
Okay.
Yeah. I think you could have arguments for either.
Could have it?
Sorry?
I didn't understand.
I said you could argue for including COA, but you could also have arguments to exclude COA.
Okay.
Not easy to judge.
Yeah. Yeah, I haven't seen your, I mean, your result with COA constraint.
I mean, what I saw is Young stuff. I mean, that's,
yeah, in the seasonal.
I had the feeling that this was similarly good at that time, but I don't know.
Yeah.
I mean, at the end, I think they preferred us to use the without cooking some for the long-term analysis.
Mm-hmm. Yeah, maybe. Yeah, I don't know. Can I will look into your seasonal solution in Jan's paper. Then we can see where the now we included. I haven't read that paper yet, so I mean in details. Yeah, okay.
Okay.
Maybe let's move on to the next. Is Axel here? Oh, okay. All right. Okay, he's not here, but he didn't tell me he won't be able to join. All right. So maybe we move to you, Chunshui. Is that okay for you, Chunshui?
Yes. I'm sharing the screen.
Okay, thanks.
Can you see my screen and hear me well?
Yeah, maybe you can speak up a bit.
Yes. So I'm going to talk about the source apportionment in Dublin and Council Point in Ireland. Here is the overview of the measurement. We have two data sets. One in Dublin is a urban background site, and the other is at Council Point. It's a rural or regional background site. And here is the monthly variation of organics, and we can see elevated concentration in winter months like November, December, January. But at the regional background site of Council Point, the variation is not so clear. And here it shows like peat is an important fuel in Ireland. Almost 1 million people in Ireland use peat to heat their homes. And in addition to peat, we have coal and wood for oil burning. And oil is the most popular choices of heating, but according to this report, oil emits less than other dirty fuels. And our previous study, we sample the direct emission from solid fuels. And in our previous study, we found peat burning is important and also wood burning. For this rolling PMF, we constrain HOA at both Dublin and Council Point from CRIPA. And for peat, wood, coal, it's also constrained at both sites, and it's from our previous study, and sea salt is only constrained at Council Point. And from our previous study, the range of a value is 0.05 to 0.2 for HOA at step of 0.05, and for the solid fuels, it's 0.1 to 0.4 at step of 0.1. And sea salt is 0.05 because we don't expect sea salt to vary so much. And bootstrap is enabled. We run 40-day window and 50 repeats. And the criteria so far is HOA versus NOx and HOA versus BC. For the morning hours, because at least rush hours, we think like HOA is exclusively and BC not exclusively from traffic, and we use p-value, and we also use multilinear relationship of these primary factors and BC, and because it's during evening hours, because these factors may contribute to the BC. We sort MO and RO based on F44, and plus not allowing MZ 43 and 44 being 0. Here is the factor profiles in doubling, and we have these 4 primary factors constraint and 2 OA factors. And the primary factors also increase the concentration in the evening hours and is from heating sources. And RVOA is flat, and SVOA is slightly elevated, could be from heating during the winter seasons. And this is the combined. If you combine peat and wood, this is biomass burning factor. And this is the time series of this. And here is more clear that the biomass burning factor increases its contribution in winter months, but in other seasons it's 2 OAs. And yes, also using this version, I can only got HOA, and for other factors, the uncertainty, the linear function is not good. I will try the latest later. And so this is a pie chart for doubling, and you can see that in winter months, it's heating factors, but in other seasons, especially in summer, it's OA. And here is the variation of 44 and F43 in different seasons and for the whole period. And yes, seems to explain some of the variation, but like I showed before, if I compare to other strategy of double constraining or iteration, you can see better separation than the unconstrained strategy. But to follow the protocol, if you like this, then we can try this. And also one thing to mention is that at higher concentration points, the unconstrained one is not capturing this. And so at the console point, yes, again, we have constrained these 4 primary factors, also the C-sort. And at this site, all factors are so flat. This is a regional background site. And it's a time series. And OA is important, as you can see here. And this is the arrow. I'll do it again. And here's the pie charts and showing all seasons OA are important. And for the variation of F44 and 43, it seems to that these 2 OAs are well separated and explain the variation pretty well. And that's it. Thank you. And any comments? Hello?
Thank you.
Yeah.
Okay, so you repeat 50 times, is it, per window?
Yeah, I understand you should cover at least every possible combination, but it's all random. Even if it's recovered, it doesn't mean that all possible combination will be covered. So I just choose 50 pits, and yeah, I can try more repeats, but it takes more time.
Yeah. Also for your 44, 43 plot, can you go to that plot?
Yes.
Yeah, here the gray points are the what are they? The gray squares.
Gray is the RVOA or MOOA. It's more oxidized.
Okay, so other the rainbow are SV.
Yeah. I'm trying to make it more clear, so I change all RVOA to gray.
So if you just wondering, when you use the sliders, you know that function, right? When you use the sliders, those are still very close to each other.
Yes. Yeah. Even if I choose all values above 0.1, it's still very close.
Yeah, I mean, when you use the slider, the latest version, you have a slider. You can, only show the data points for a certain time period. If at that time point your SV and LV are not mixed, then I think it will be still okay. But like one thing you should be cautious is right here. You see, you color code those data points by the OA masses, right? Like there are many noisy points. So for me, I will make them smaller and also hide it. Those points which are smaller than 2 micrograms, for example.
Okay.
Then you will see more clearly are those points are actually moving around together with your PMF. I mean the factor profiles.
You mean the background data points to be smaller, or the squares, our SV RV to be smaller?
Sorry?
So what do you mean by smaller? It's the data points to be smaller?
Yeah. Or
okay.
Because some of the points were covered underneath.
Yes.
Most of them were like the noise.
Okay.
But you don't know what are the. I mean, those red points might be a bit suspicious. I will be more worried about those points because those are high mass points. But
I agree. I fully agree. Yeah. I'm also quite worried here.
Okay. So
how many factors with 43 and 44 do you have? Oh, actually, I asked differently. So here, the colored PMF result points are just SV and LV.
Yeah. Yes, SV and RV.
So you subtracted all the other factors.
Yeah, it is subtracted.
Subtracted. And
yeah.
Can you show me the factor profiles? I think it's in slide 10 or 9.
Yeah.
Okay, so basically 44 you just have in LV and SV.
Okay. So the SV is also 44 is higher?
Yes.
Okay. Yeah, but the 44 is still rather smaller than the LV.
Yeah. Yes.
So basically coal and peat, they have 43, well, also wood.
Yeah, they have quite a bit.
Yeah, I mean the 44-43 plot, in particular the 43 axis, doesn't really make sense to study anymore because you don't have 43 in your always.
Yeah.
You always contain only 44.
Might be like you are overfitting, you know.
Yeah, or basically just removing out. You're subtracting all in the 43 channel. You're subtracting all the other factors that have high contributions in 43. So you end up having noise there. Can you go back to the 43-44 plot? Because it's the red points. The red points seem to be off in the x-axis, right? Line 12.
Yeah.
Those should be also valid, but yeah.
Yeah, I mean they are off in the x-axis on the right. So, and
yeah,
x is 43. So probably this is happening because you're subtracting the other, you know, the peat, wood that have high 43, high contributions on 43, and then you're making basically noisy points there. You know what I mean?
Yes. But before I also tried to not including wood and coal, I still see similar things.
Yeah. No, I mean maybe. Can you go back to the factor profile?
Factor profile?
Yeah. Do you know which of these factors, well, peat, wood, or coal, which has the highest mass contribution, relative mass contribution to 43? Is it coal or peat?
I will check later, but coal has lower concentration. I mean absolute concentration, so I can only guess. I think it's peat.
Maybe peat. Maybe, you know, if you keep that in the 44-43 space, then I guess the peat point will be more on the right side, capturing also the variability of the red points. But that obviously is not really what we want to see in the OA in the 43-44 plot, because we want to see the movement of the aged factors. So my point is that I think the variability is captured, it's well captured, because probably peat is there that captures these high concentration points. But it's
And also, when you look at the diagonal of your SV, coal, wood, peat, HOA, they are very similar.
Yeah, because they are also heating sources.
Yeah. In my opinion, in winter, that these points are on the left-hand side with little 43 for the always. It's actually fine. This is what you expect. Maybe in summer a little bit less. Although, I'm not sure in Ireland how much the biogenic really is. It could still be that actually causes maybe peat and so on is still used for, I don't know, maybe cooking or a little bit of heating. In Ireland it's cold the whole year. So I don't know. Maybe it's always a bit used. What one could do to check, for the summer data, if there shouldn't be any secondary.
Yeah, this is the data points for summer.
This is summer. Yeah, but one could take the original data and then, not subtracting the POA, and then correlate the F43 or so with temperature. Because if there's a biogenic factor which we usually expect to be a bit more on the right, it usually then correlates with temperature. And if there's nothing like that happening, then maybe the biogenic contribution is just rather small in Ireland, which is not impossible.
Okay,
because
good
it's just
point.
always a bit cold and so on. But I don't know. Still, yeah, still a bit weird. Yeah, that it stays on the left hand side so strong. Yeah. But I don't know. Do you know if there has been in Ireland any measurements of, for example, the past of like pinic acid or something like that, like terpene oxidation products, to judge if the biogenic contribution is significant?
I don't see much previous study about biogenic in island, but I will see if the concentration, the temperature affects the concentration during summer.
Yeah.
Yeah.
I mean, the Cork people, I could imagine maybe they did some.
Yeah.
I mean, or the people, some people in Cork maybe did some measurements on organic markers, but I don't know. I don't have a overview. But I mean, that's a question. I mean, either something is a bit wrong, that you take the POA takes away the 43 from the secondary, or there is nothing, and then the hypothesis would need to be that there's very little biogenic terpene chemistry, because terpene we kind of know when it's rather fresh, there should be quite a lot.
Yeah.
But I mean, the super high, just only 44 is a little bit suspicious. So maybe we are just, because we use too many things, then we kind of eat up all 43 with the primaries. It really seems like in summer.
Yeah, but if I constrain the SVOA and constrain again, it seems better separated than free PMF.
Yeah. Okay.
So here's the question: which solution should we use?
But I mean, here you still use this, you know, the distance, right? Like.
Yeah.
So you should not use it for this. I mean, like the reason why you get this separation is because of that, not because of.
Yes, I got your point. But even if we include it, I will still expect the same. I will double check it, but I mean, the final results will still be like this because it's only like minor data points here.
Okay. But another thing is, here you included cold combustion factor, but why you only run the mass to charge ratio into 100?
It's because like at higher MZs, we suspect the signal to noise ratio is not so good, and also coal burning is not very important. Not very important because we have this coal band. You can see the pie charts. So it's coal is always minor, like.
Yeah, but I mean, like, it's. I think if you are not confident about variables larger than 100, then it will be dangerous to have coal. Because it might be very difficult to differentiate it from the HOA, you know what I mean?
Yes, I've tested MZ up to the whole range up to 149. The overall
SSM, is it?
Yeah, SSM.
I think it's 120 should be, not 140.
Yeah. Yes, but I just tested before and the results are similar.
Okay, but is the HOA kind of correlate with coal as well?
If you see the diurnal oil peaks in the evening, so all factors are correlated if we include all the periods.
Yeah, but at least when you see, did you see the improvement for the multilinear regression when you including coal combustion factors?
I haven't tested, but I would say they are similar because BC also shows higher concentration in the evening, and the multilinear is showing similar thing.
No, I mean when you with and without coal.
Yeah, I haven't tested, but all are showing higher concentration in the evening. So they should show similar things. Like, because the reason we constrain code is because it is contributing something, but we want constrain it because we want to see how much the upper limits or something like that to show his contribution.
Yeah. So one thing, if you want to run less repeats, maybe you can. I think your step for the HOA is 0.05, is it?
Yes.
Maybe you just use 0.1 if you want to decrease the number of runs. But I mean, ideally, if you want this many factors, then maybe still need to go up a bit for your repeats. But
Okay.
like,
I will try. Yeah.
Yeah, but like, I think how okay. I mean, you have this many factors. Did you validate it already, like in your seasonal runs, for example?
What validated? Because in seasonal run we also constrain these factors.
Yeah, I mean, if you, for example, if you just constrain HOA, let's say, all those peat, wood, coal factors.
No.
No.
In free PMF, we cannot separate all the primary factors when they are all showing like similar time series, because all are elevated in the evening. Even HOA is elevated in the evening, and because we have oil heating in Ireland, so I think it's from oil heating for HOA.
Okay. Yeah. This is difficult to justify when you have this many number of factors. Yeah. All right.
I mean, did you do the bootstrap for the summer solution?
Summer solution for bootstrap.
Seasonal summer bootstrap. I mean, if contribution varies a lot, then I would say that factor is maybe not so. I mean, it's more uncertain that it's maybe not even present.
Yeah, you can see the variation of this error estimation.
No, that's not what Andre meant.
For the summer seasonal solution.
Yeah, not for the rolling.
For summer bootstrap, yeah, I have it in other slides, but not here. I will get back to you later, maybe.
Yeah, but like the question is more about if the contribution of those primary factors vary a lot during the bootstrap, or if it's not. If it is, then it means maybe those not stable. Then will be still That's one way to justify if those are if you will
true
have
factors.
factors. Yeah. Okay.
Okay. Yeah. So I will
Yeah,
stop.
yeah, but like Andre, do you think for this case we should add them up, or the wood, peat, coal together, or maybe, I mean, not a coal, but like peat and wood together at least? Let's say biomass burning or solid fuel.
I mean, I guess in winter, this distinction is probably good. I mean, I think this has been partly published now. Also, this distinction, but and for summer, I'm less sure. Yeah, if could imagine maybe only one of the three is maybe prevailing really. I mean, I don't know. For example, if coal is really used in summer, I would doubt a little bit. But peat and wood, maybe that's possible. I mean, for coal, I would assume that's used less. I don't know. It's just a gut feeling.
Yes.
I don't know. I don't know how people do that. It's surely you. Yeah, I'm not sure. Yeah, I would look at the diesel solution maybe a little bit more closely if you the summer solution if you exclude one or the other, or how stable it is for individual. And maybe if you reduce, maybe which ones are then more stable. I don't know. I would play with the diesel solution.
Yes, I will try later. Thank you.
Thanks. Okay, so Anna, would you mind to start then? Yeah, might be a bit early, but
Yeah, I can do it.
By the way, for all, Biden just passed Trump in Pennsylvania, so things are good.
oh, Biden just won.
Well, I think he will
yes.
win nearly for sure, yeah, but now it's really, the numbers are now have the right color. Everything's blue, it's outstanding. A narrow.
Good news
state.
for us.
Well, I'm going to start. So I'm going to present the results for North Kensington in London, and just as as a recap. So North Kensington is a monitoring station located in London, and it's characterized as a urban background, and it's located quite centrally, but it's in a residential area. As you can see that there are some houses around, and the main road that will be that one, but it's more than 100 meters away. We have ACSM measurements from September 2015 to February 2018, and with some co-located gas measurements and black carbon measurements. So despite there's this time series from September 2015, I started doing the seasonal analysis using some some profiles that they were collected in the same site in 2012 in a previous project. But working with Ian and also discussing internally, we found that there might be some problems with those profiles, especially for COA, because we realized that the COA profile that we were using to constrain our profiles didn't have any F44. So for this run that I'm going to show you today, I used the CRIPA profiles from Paris, and I have used them for all the primary profiles. And also I've been just concentrated in the last year of data from end of 2016 to February 2018. I've been using a random A value of between 0 and 0.4, bootstrap enable for the seasonal analysis and 100 repeats. And this is a list of criteria that I've been using. So for HOA, I have been looking at the p-value less than 0.05 for the R-squares between HOA to NOx. For BBOA, I have used the R-square between BBOA to black carbon wood burning, also using the p-value. For the COA, I have used the ratio between concentrations at 12 at 1 and compared to the concentrations between 10 and 11, and it should be greater than 1. And for the oxidized organic aerosols, I have been using the F44 and F43, using F44 to sort and monitoring F43 and not allowing to be 0. So here you can see the winter profile. So the one between February 16, 17 and the winter 17, 18. And in those 2 winters, I could detect 5-factor solution, so HOA, BBOA, COA, and a more oxidized a more oxidized OA, and then a less oxidized one. But there's a bit of a difference. So for the first winter, I would say that this is mostly like an HBBOA because it has quite a lot of MZ60 and also 73. And when looking at the correlations with the black carbon, the wood burning part, it is highly correlated, but it looks like a slightly different compared to the BBOA profile. So I prefer it to separate the 2 of them. And for the second winter, I could distinguish the 2, a more oxidized and a less oxidized OA. So this is the uncertainty for the different profiles calculated from the graphs that I'm going to show you next, and they are quite okay, except for the less oxidized one for the second winter. And so this is the dispersion graphs for the different factors for the first winter, and they look quite all right. I would say that there's not much dispersion, maybe a bit in the more oxidized OA, but I think that it's still within expected variability. And those are the profiles for the second the error quantification for the second winter. And I would say this is the factor that it has the highest slope and therefore the highest uncertainty. But looking at the distribution of the standard deviation versus the mean, I think that it looks quite spot on. So I think that we just have, I don't know what to do with that. And yeah, maybe with the more oxidized one, there's a bit of a dispersion, but still I would say that it is within expected boundaries. This is the time series for the first winter, and those are the diurnals, and we could see that they follow more or less the expected variation. So HOA has the typical morning rush hour and evening rush hour. BBOA, the concentrations are high and towards night, and cooking aerosol, and it has slightly higher concentrations during lunchtime, more or less, and especially towards the evening. And then we have the 2 OA factors. Then that will be for the second winter, and as well, I would say that the diurnals are kind of they follow the expected patterns for them. And this is the profiles for spring 2017, and as well we could distinguish the best solution will be the 5-factor solution, and those will be the profiles, and this is the uncertainty for each of the profiles, and still they are quite good for this season. And those will be the spread of the values, and they are quite, I mean, they show good spread within the normal boundaries, I would say. This is the time series as well, and that will be the typical diurnal patterns for HOA, BBOA, cooking, the COA, and the more oxidized and the less oxidized organic aerosols. Will be for the summer one. These are the profiles, and in this in summer we could not distinguish a BBOA factor. So for the primary ones, we will have just HOA and COA, and we could distinguish still the two OA factors, and as well sorry, this is a mistake. So the uncertainty of the profiles are still within, I mean, they show a good uncertainty boundaries, and this will be the spread of the values And those will be the diurnals. And what I found is maybe the HOA, it has a bit of a strange, I would say, like higher concentrations, especially in the very early hours of the day. But it might be also, I think that maybe something driven by the boundary layer height, and that's something to look maybe slightly deeper. And for autumn 2017, there was no clear distinction between two OA factors. So there's only one OA factor, and again back the three BBOA factors. And so again, sorry, I just missed that. I need to update this table. But looking at the values, they are quite okay. Especially for the for HOA and BBOA in terms of the uncertainty. Maybe the Cooking aerosol, it's showing like a larger spread of values, but still I would say that it is within acceptable, it has an acceptable shape. And this is the OA factor, and showing like a good 7% of uncertainty, so it's quite good. And those are the typical the profiles for the four factors. So that will be HOA, BBOA, COA, and OA factor. And that will be the separation for the two OA factors for the different seasons that they could be distinguished. So that will be the first winter that there was the second, like the LOOA will be more like an H biomass burning factor, but I think that still it quite distinguished well. It's quite well separated, and this is the spring one, and the summer ones that they're showing more dispersion versus the two winter ones that the dispersion of the points, they are more kind of like a straight or a vertical line. And that will be and that's the contribution for the different factors, as well. The OA factors, they are the ones that they are showing like the greatest contribution, and then like the other ones is just varying from season to season. And just to mention that the LOOA factor from the first winter, that it will be more associated to the H BBOA factor. It's contributing quite a lot, almost the same as a more oxidized factor. And that will be me. So this is, I would say that, I don't know, unless you have some issues, I will be happy with the seasonal solution. And now if I can start with the rolling one soon. So that will be me. If you have any comments or something that you think that I would need to check, double check, or.
Thanks, Anna. I have a feeling looks good most. I mean, maybe the question for Francesco or I mean, did we now implement in Sophie that we can also look at the uncertainty of OOA? I mean, the sum of SVLV.
Yes.
Yeah, it's here. Yeah.
Okay.
Yeah.
I mean, I would recommend to use that then. I mean, somehow, because I mean, you could say for a politician or for air quality representative, the distinction of LV SVOA is anyway not so important. It's anyway a bit tricky. Mm-hmm. But the important thing is that is the sum. I mean, the total OOA and how uncertain that is. So I would rather. I would provide that number as well, because that's the important number to say, this is secondary contribution plus minus that. So
okay.
That would be.
So
I think that would be for most people. I mean, one could add that, but obviously you can add that also then when you do the rolling.
Mm-hmm. So you mean, for instance, here in this graph, like adding the two LOOA and the MOOA and just plot the two of them together as a.
Yeah, I think Francesca's implemented it, so you can.
Okay, I can just.
So it sums it up and then also, yeah, so it produces this graph automatically.
Okay.
Because you need to, or this need to be. Am I right?
Yeah, they need to be averaged together first, exactly. So
you
know what this feature is in SOFI?
Yeah, I guess that when you do the factor specification, when you
exactly, yeah.
You add them together, and then it will be generating an extra wave.
Yeah, perfect. Yeah, that's it.
Yeah, I
But
can.
I mean, the spread is not. I mean, it's not just added, right? I mean, you recalculate.
It's completely recalculated. Yeah.
Yeah, exactly. Okay.
Yeah.
Good. And I mean, the other comment I have now, I mean, it includes also actually Junjui. I mean, if one looks now at this solution, which is in London, I mean, it's probably not so different than Ireland. I mean, the 44-43 plot looks much more how one would expect. I mean, that kind of in the warmer season, in spring or sometimes in summer, you're more on the right-hand side, and on the winter, you're more to the left, I mean, or a more straight line, as Anna pointed out. So I think this looks much more as I would expect it with a considerable amount of bits. So I don't know. So if one believes maybe London is not so different, I mean, the rural part or the regional part than in Ireland, then that somehow I really have a feeling maybe it's rather a problem, yeah, that maybe that you have so many primary factors in summer is just eating up the 43 from the less oxidized over.
Yes, very good point. Yeah.
Yeah, here I think also why this, for example, the winter 16, 17, the reason why it's on a bit like shift to the right, it's not like perfectly vertical, I guess is, you know, for your SVO or LOA is mixed a bit. I mean, it's aged BBOA here. So
yeah, look,
that's true. There the separation was not so good. Yeah.
Well,
we'll see how the rolling looks like. Maybe it's getting better.
Yeah.
Yeah.
The rolling could. I mean, what was the A value you allowed for the BBOA?
Up to 0.4.
Okay. Yeah, I feel that should be enough.
Mm-hmm.
Yeah.
That the mean one for this winter. So,
yeah, that's the one.
Yeah, it's 0.175.
It has quite high contribution of 44, this reference spectra, I guess, in BBOA factor.
Can you make it big one more time?
The 44 in BBOA is quite high.
Which reference spectra is this?
I think Anna said it's Krippas.
Yeah, I used the Paris city center.
Yeah. I'm not now 100% remember. I mean, I think we're mostly using always the HOA and the COA because there we're convinced that's really good. The BBOA, I don't know. I mean, there I think we're less.
I remember you got your own BBOA, didn't you?
Sorry, say that again.
I mean, I think you got your own BBOA from.
Yeah, but because our own HOA and COA were a bit, well, especially the COA were a bit suspicious.
No, I mean BBOA.
How did the BBOA look like?
Did you get your own BBOA?
We've got it, but I haven't properly checked and compared with this one. I can do it as well.
Yeah, I will compare them. Yeah.
Yeah.
Yeah, I mean, one thing you could try is just do a few runs and don't constrain BBOA. See, I mean, or you already get your own BBOA, then you just do the similar test.
Or use the Sally ings.
Yeah, NG's 2011, 2010, I think. Right.
I mean that's used by many, and I mean maybe that one in general works better.
Yeah, that one is.
It's true. I mean that's maybe the only thing that was worth testing a little bit. I mean maybe use a different BBA factor because it's because as you said, I mean the less oxidized OA is maybe a little bit too much mixed, and the BBA actually too much 44. So it's actually with two factors a little bit in between. So.
Yeah, but I wasn't sure just because the 4-factor solution looked okay as well, but because I know that I had also this 5-factor solution in the other winter, I was kind of like, well, maybe it's good just to have like a consistent 5-factor solution. But obviously, like looking at the seasonal one, this one, it looks very similar to wood burning. It's not exactly the same, I think, but it looks very, very similar. But yeah, I can try to run, for instance, the 2 winters with our own BBOA profile and see if it makes a difference with the factor. Yeah.
Yeah. Or the NG as well. Try the NG as well.
Can you provide that for me, or is it somewhere where
I can send you the link.
Okay. Okay.
Yeah.
But in general, it looks good. I would say.
Okay. Well, I will try that and then start with the
Yeah.
Good. I stop sharing then.
Okay.
Thank you.
I think Axel is not here, so we should be able to have our coffee break. Yeah, we can come back. Do you want to come back earlier or later?
Earlier.
Earlier, okay. Yeah. Sorry.
15:30. This time.
We were so okay. Petrol, are you here?
Me?
No, Petrol. Or Redek. They are not here.
Petra shall be here, no?
Yes, she's here. Okay. But like maybe we come back like 3:40. Then we start with Francesco. Is that okay for you?
That's good. That's good. Yeah. Yeah.
Then we start. Then we keep the same time slot for Petrol. Then Mina.
Okay.
Sounds good.
And then we can finish earlier. Good.
Good.
Yeah. See you later then.
See you later.
Francesco.
Yeah, here.
Maybe you can share your screen.
Sure. So. Can you all see it?
Yeah.
Excellent. Jan, can you see the cursor here?
Wait a second.
I mean, do you see the cursor on the screen, or do you see it now?
No.
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 And yes, and now?
No.
No.
You can enlarge it and you know you can.
So you don't see the mouse cursor right now.
No.
Just, and now? No.
Wait a second. No.
Oh.
Maybe you can, you know, present mode and then right click.
Well, maybe I will just I have another screen. Maybe I'll just disconnect the screen. That's
yeah.
Give me a second.
Here it is, so we can see it.
Okay, can you hear me?
Yes.
Yeah.
Okay. And do you see the cursor now, the mouse?
Yeah.
Yes.
Oh, excellent. Okay. Can I start? Or shall I wait one more minute?
Maybe one, yeah.
1 more minute?
Yeah.
Okay.
Let's see.
Just start.
Yeah. So whenever you're ready, just go.
Okay, excellent. In that case, I will start. So good afternoon. I will talk about the rolling PMF results of Hohenpeisenberg. That's mostly work from Julia Sosedova. Unfortunately, she couldn't be here, so I will present the results. That's work we did, or we are actually doing for the German weather service. It's the Deutsche Wetterdienst. They are responsible for this station, and they wanted to have the databases and data analyzed. So that's why we're analyzing this the full ESSM data set they have so far. Hohenpeisenberg is the only GOV station they have in Germany. It's on the Peisenberg Mountain. It's roughly 1,000 meters above sea level in the southern part of Germany. It's in Bavaria. That's where the Oktoberfest comes from, just to know roughly more or less where it is. And if I recall correctly, I think Julia already presented the seasonal PMF, the seasonal results in late spring. So I'm just going to talk about the rolling results here. Just as an overview, here it's work that Michael Elsasser did a couple of years ago on the ESSM dataset. As you can see, the ESSM, the ESSM data is basically 2/3, half is organics. Then you have most also inorganics. From that, it's basically nitrate. This is an early PMF result Michael did in 2014, and the station is on this mountain, so it's basically the aerosol that reaches the station is mostly it's basically advected air, and the aerosol is in H. So we expect typically OA, LV, and SV, and very little contribution from primaries. So that's already what Michael pointed out in 2014. Yeah. Two other interesting facts, important facts here is that in particular in Bavaria in winter, they burn waste from the forest, so we expect biomass burning contributions in winter to be high. And also on this on the Hohenpeißenberg station, they have a canteen, so we also expect some very local cooking contributions from for this analysis. Good. Then what we did was a quick analysis on the key variables before even starting the rolling or the PNF results or PNF analysis. And we concluded that based on the NZ60 plots on actually the fraction of 60 that you see on the left side, so the A graph, that F60 is mostly always higher than the Nye-Cubic threshold of 3 per mil. So it's the threshold is here. Winter is systematically always above. In summer, for the first 2 summers, 2017, 2018, we are higher than the average. In 2019, there are some parts, some episodes where we're really on the edge. But we still decided to keep biomass burning in over the entire analysis, because even for the episodes where on average it's really on the edge of this threshold, F60 still shows that they will not pattern. So it's still high at night, early night, and low during the day. So it's not just noisy. That's the point. Then on the right side, the B graph shows F55 against F57. Sorry, F57 against F55. Sorry, it's in absolute terms. So it's MZ57 against MZ55. This nicely shows that you have some different slopes there. So if you were going to just do a one PNF over all data sets, you have to go for 3 factors at least, so for 2 factors at least to capture this triangular shape. Since we're doing the rolling, we just allow the HOA factor here to just adapt to these data. Then for the 43, 44 analysis, this is winter, summer. So on left side you have winter, right side you have summer. The point here is that for in this plot you have for all seasons, that's just now winter and summer, but throughout all seasons you always have a linear shape of these points. So even if you take, for example, 2 weeks episode, you know, it's always these points always describe a line roughly. So from this we conclude that we are confident, you know, to keep in 2 OA factors for the rolling analysis. For the analysis, for the rolling analysis itself, these are the parameters we use. So we're modeling 2 POA factors. We constrained an HOA and biomass burning factor, and we allowed for 2 unconstrained OA factors. We had a 14 days window, and with a daily shift, 25 repeats, and we, as already mentioned, we constrained HOA and biomass burning, although I'm not sure anymore whether we constrained HOA or cooking from CRIPA. So this I'm not really sure anymore. The A values we allowed from 0 to 0.4 in independent random variation, and it was an unblocked bootstrap. Then for the criteria we used for HOA and biomass burning, we used a multilinear regression between VC and actually HOA and biomass burning. For the OAs, we were sorting at position number 3, the one with higher 43, position number 4, the one with higher 44. And we were also sorting based on the comparison of the second highest score. So we just allowed, you know, in the SV fact, the SV OA to have the highest MZ44, MZ43 contributions. Same for the LV. LV is supposed to have also highest MZ44 in its vector profile. Then we were also monitoring the Euclidean distance between in the 44-43 plot for the OAs, and we were also monitoring F55 for the SV OA. For criterion number 2, so for monitoring F43 for the SBOA, this is the score plot on the left side, and the blue points are the selected one based on this second neighbor threshold analysis. As you can see, there is a region here in winter 2018 where we almost have no points selected. So if you just use the second highest score analysis, due to this, we are basically losing roughly 10% of the points. So we were having roughly 10% of non-model time points. And that's why we also performed a manual sensitivity analysis just over this period. On the right side, you see just the very preliminary graph. It's not the full graph. So we were basically monitoring the amount of missing time points and also the PMF error for all these factors as a function of the threshold for the score here. So we were varying the threshold here from nothing, that's just as is, to then arbitrary using 0.08. So basically just do the line here and then 0.06, 0.04. And we're monitoring then how this number of missing time points and the PMF errors varies. Here we just report the number of missing time points. That seems to be ideal for 0.06. So it's afterwards, it's not gonna decrease way more. And I think the PMF errors, they look more or less the same here through this range. Then for the Euclidean distance, this is the score value on the left side. Here we don't have any threshold. So what we did was also to perform a manual sensitivity analysis. That is, I think, still ongoing here. You just have 3 points. So Julia is still working on this. And basically, we're doing the same thing as I was presented before. So we're monitoring the amount of missing time points and the PMF error as a function of the threshold that we're testing here, with the aim to have to receive a good threshold based on based on these parameters. The results I'm going to show here are for the threshold 0.06. And we are also monitoring F55 in SVOA. This is the score plot here. And Julia just cut here, so just apply the threshold here. Although we are still thinking about doing sensitivity analysis also over this criterion. And then it's also a question to you. Maybe you have also seen this because the SVOA in our result contains quite some F55. So we were just curious about this, and yeah, maybe you also have explanations for why 55 should be present in SVOA. What we can discuss afterwards. To the results, this is on the left side, a time series of these 4 factors. Below you have the scaled residuals over time. Right side contains the diurnal cycle. We are actually rather happy here. So we have green line from the residual analysis. So we have unscattered, it's basically random around 0 over time. So from point of view of the scale residuals, this looks actually good. Diurnal cycle looks good to us. We have to keep in mind that it's basically all a vectored aged aerosol here. So what you see here, that's just now the average over these 3 years. This is basically describing the advection effect. You see it also more clear in the next slide. You have here the separation between winter and summer diurnal cycles. As you can see, in winter, the diurnals, they start to increase around 8 o'clock. In summer, a bit earlier because sunrise happens earlier. So the increase here basically is, and the diurnal cycle is due to meteorological effect here basically. What is also nice is that there was, I think in 2000, well, I don't know the year exactly, but there were some episodes where they had some events and grill parties up there. And so the diurnal cycle here, they don't consider these events. The next slide here in summer contains these events. So we expect actually some cooking activity, some barbecues, biomass burning, and this is actually nicely portioned in the proper factor. So there is a peak here for the first factor. Now this is labeled HOA, but this should be actually HOA and cooking. And this is then the biomass burning factor. Then we have the factor profiles. So these are the 4 factor profiles: HOA cooking, biomass burning, the SB that contains this relatively high 55, and LV. And the scaled residuals here over the variables show us that actually it's rather overestimated. So you're rather on the edge of this overfitting. So I think going to higher number of factors doesn't make sense here. So I think 4 factors is the highest, the most we can do here. Yeah. Overall, for the scaled residuals, we are rather happy. So on the right side, you have the scaled residual histogram. It's unimodal. We are slightly overestimating. That's seen from the shape here. So the negative part, the negative wing, is slightly higher. Also, if you have a look at the full matrix, the full scaled residual matrix, it's actually good because it's random. So you see blue and red, but actually blue is a bit more dominating. So that's the hint that it's more overestimated. But overall, actually, still good because it still appears to be random. So there are no strong systematic effects here. Then the pie charts that show that it's mostly aged errors. Also, we have huge contributions for SV and for LV. So it's basically 90% is OA, and then 10% is roughly the primaries HOA and HOA cooking and biomass burning. This is for the 3 different years. I also would like to stress the 43-44 plot. On the left side, it's for summer 2019. On the right side, it's then for spring 2018. The OAs are always well separated. It's nice that in summer the SV really resides on the right side, like in this plot on the left side. In winter, fall, spring, the SV is more on the left side, and then you have actually in spring and in fall you have this movement, from left to right, so or backwards. So it's actually going then from the biogenic region on the right side to the biomass burning affected or influenced region on the left side. This is actually also evident from the pie charts. There is no strong, seasonal pattern for the primaries. For example, biomass burning is more or less always constant. So the mass is more or less constant throughout the year. Even though F60 varies, has a seasonality. So let me just maybe jump back. I'm almost there. Here. So F60 is really high in winter and it's relatively low in summer. So we have a strong seasonal pattern. And actually, what we believe is that, let me go back to the OA, to the 44-43 plot. What we believe is that the SBOA in winter has really strong influence of biomass burning. So the 60 is actually, the 60 winter is also highly explained by the SBOA. So we have really SBOA with biomass burning influence in winter, and the SBOA in summer is most likely biogenic, has biogenic influences. Speaking about the errors, these are the histograms of the standard deviations normalized by their mean for these 4 factors. So the errors is basically then we take as error the center of the distribution. So the log normal fit here shows roughly 40% error for HOA or cooking, 35% error for biomass burning, 46 for SV, and 24 for LV. Relatively high errors. Maybe if we then go to a higher number of repeats, because right now we just have 25 repeats. So if we increase that, we hope to also decrease the error a bit. And from this plot, we also want to investigate a bit further what happens actually here for the LV plot, you see it's sort of bimodal. So we have episodes here with probably very high concentrations that don't really fit in here. So we have to investigate a bit further what is going on here. That's the summary of the contributions for all these factors. And here just in the summary, the last slide, that shows again that we have roughly 5% HO cooking, 5% biomass burning. That is rather constant over all these, over the 3 years. So overall, we have roughly 90% OA, 10% primaries. This is actually similar through all these years, but also very similar to the results that Michael had years ago. Yeah, so that's all from my side.
Thank you, Francesco.
Let me just connect the logic screen. So,
I have one.
Go ahead, Andre.
I have one question on the 4443 plot.
Yeah.
So, I mean,
yeah,
this includes different winters, right, or so?
No, these are just 2 episodes. Here it's just June, July, August 2019, and here is that spring 2018.
Okay. Oh, you didn't show the winter here, no? Okay.
No, we just picked 2 episodes here. Yeah. Or she just picked 2 episodes.
I see. Okay. They don't mind. They don't have a question.
Okay. Yeah.
So here, I think in your place in this data set, the overall mass concentration is low, right?
Where do I see this?
I guess, and also, one of your comments saying your SVOA might be also mixed with your BBOA.
Well, actually, not really mixed. I actually more assume that it's really
affected.
Well, it could be also mixed. Yeah, maybe aged primary biomass burning, or also really the processed secondary biomass burning. Yeah.
Yeah. So, but like, I feel it's. I mean, I'm not convinced because if you okay, maybe you need to show me the profiles during that episode of the SVOA, I guess, then, because I think overall the BBOA concentration is not so high.
Yeah, that's true.
And also the total OA concentration is also not high. And I don't see why it could go to another factor. You know what I mean?
You mean the biomass burning contribution?
Yeah, exactly. So I don't think in the SVOA you will have some like biomass burning source affected. For that comment, I don't agree with you because I think the BBOA concentration here is not high enough. So yeah, I mean, normally
we try to investigate further. Yeah, that's.
So normally we see this phenomenon when the BBOA source is significant and and it's also when that concentration is quite high. So yeah, and another thing is I think it will be better if Julia can actually follow the protocol to try if we don't use those thresholds at all for those 44 and 43. I mean, for OA factors, don't use those thresholds at all. Just take all and see how.
So you mean this year?
Yeah. I mean, you can sort it, but don't use the distance, for example.
Yeah.
And also here, the 55, those things. I see there are some like episode where has very high 55 for your less oxidized OA. Is it in your criteria plot?
Do you also have this in other data sets? I mean, this high 55 for SV. Is this normal?
Yeah, this is normal. It's normal.
Yeah.
Okay.
I think it's okay. I mean, like your SVO or less oxidized. There's some other pattern. I mean, 55, 57. I guess is still okay.
Okay, good, good. So there's
So
no.
I don't know why you have such a criterion that only select the 55 within this factor is smaller than 0.06, I think.
Sorry, say the last thing again.
Can you show the criteria plot again?
Yeah.
The criteria. Yeah, here.
Yeah.
One. The other. 2009, please. Slide 9.
Slide 9. Yeah.
Yeah. Maybe another 10.
Here.
Yeah. Here. Yeah. So the 55 in less oxidized OA.
Yeah.
Yeah. I don't know. I mean, maybe this you know increasing there's some episode there. It doesn't mean. I mean, I think fully less oxidized OA. You don't need any criteria. Just need the 43 is not 0. Then you can explain how this less oxidized OA is affected by what kind of sources. For example, here 55 is really high during this episode, but maybe look into the profiles during this time period to dig in to see what the sources could be. I mean,
yeah, I think this is this is this grill event they had in at Home Passengers. I think this is.
Yeah.
Maybe this barbecue cooking event.
Yeah. And that
was
cooking is not sufficient to capture all the variability, so this is also then inserted into the OA. So I think this is real. Probably should keep this in.
Yeah, I don't think
this cooking peak, was this at the same time as this? I mean, was it kind of a short episode only?
I'm not sure. I have this. I see this here.
Hi, it's
I will
Julia.
investigate further.
Hi, Julia.
Hey.
It was a very short-term episode, like over 2 hours, and then it was gone.
Okay.
Over 2 days in a row.
So maybe they had a big barbecue party. They were eating 10 pigs or something.
I think it's this here, right?
Yeah.
Yeah.
It's this peak here.
Mm-hmm.
Yeah.
Okay.
Yeah.
I mean, it's okay to leave it there because
and then you just have some residual in the, or something is then moving to the SV or LVOA, but I think that's a detail. I mean, this episode you can obviously not capture by this channel not so well. But besides that episode, that there's no other evidence that you would.
Also, the previous summer, 2017, it was a similar 2 days with similar behavior. They're just less intensive as in summer 2018.
This year? In
summer.
Right.
In summer, somewhere in summer.
I mean, maybe it's worthwhile to ask them if they. I mean, I could have well imagined they have maybe special event up there. In summer.
Sure.
I mean, like we in Zurich have whatever these special events, maybe like in close to our station, but maybe they also have something there.
Yeah,
I could imagine. But it's a question how we deal with maybe such special episodes. I mean, where it's clear that this is not typical. But I mean, really special event. I mean, like when for Zurich, we left also these events, right? I mean, when we had these local.
Yeah, it was the most improperly apportioned, but we still had to. I think that PMF result there used still the SVOA to then capture the full variability of this 55, 57.
Yeah.
So it was a bit a different solution than the overall solution. It's true. Yeah.
Is it cut actually? Probably it's cut. It's probably even higher than here on this graph. Concentration. Because
Yeah, it can be the cut here.
Because in the diurnal it was really even,
maybe yeah.
Otherwise I think it should not pop up.
Yeah, it seems to be cuts. Yeah.
Yeah, in terms of averaging, they are outliers for sure.
Yeah, I don't know. I mean, not sure. Ian, maybe we have to think if we want to exclude such an episode, or we want to, or one should somehow, one would need to discuss at least in the supplementary.
I don't know. I mean, like, I think every data set have some events.
Yeah.
How,
yeah, but I mean, it's in the diurnal. It looks quite strong, right?
Yeah.
And then you have to say it's cooking, and then you have to somehow either you have to discuss it or you have to skip it. I mean, because it's too strong.
Yeah.
So it's still, I think, in this case, you need to make a decision. I'm not sure which decision is better. And surely, if you would have a standalone paper on an whole Heisenberg, it would be detail.
Yeah.
But I mean, if it's overview, obviously we don't have.
Hey, for the overview, it's better to remove the.
Yeah, I guess so.
Yeah.
Yeah, one could mention it that it's somehow these days there were huge peaks of imitated. Maybe we can try to find out what kind of event it was. Should mention it. That's it. Maybe show just the time profile in the supplementaries. I think in this case you need to show it. I mean, if it's just slightly enhanced or it's kind of captured more or less, then it's fine. Okay. But it looks good. Good work, Julia.
Thank you, Andre.
Agree.
But it's for that year that we want to include in this overview paper. I mean, as Ian said, it would be good if one could somehow follow the procedure then at the end. So it will not change much results, but I mean somehow to be consistent otherwise.
Yeah, sure.
Okay.
Francisco, can I ask a question?
Sure, anytime.
Can you explain once again why you choose F43 above a certain value and not like we did for selecting F43 not being 0, but you select a threshold instead?
Well, we just, where is it? You mean the criteria list, right?
Yeah, yes.
So we just use 43, 44 for sorting reasons, and then we also added this. We were basically just excluding PMF runs where another factor was higher in 43 or 44. This will typically suggest also mixing. But in reality, I mean, you can also. I'm not sure.
Show the next slide.
Yeah.
Show the next slide.
Yeah.
Yeah, so here it was just low coverage for the periods with a low score. That's why we set this threshold for a manual choice.
I mean, if we take everything, if you don't separate, if you don't apply any threshold, then you take everything, all these results, right? And then here, you are too low. Yeah, so far in your protocol, you just say it has to be higher than 0. That's it, right?
Yeah, exactly.
So basically, all these runs will be considered afterwards.
Yeah, I don't know. These down excursions are. I mean, are these very low concentrations, or is there something specific about these events where it goes down?
I think these are those periods where in the F44, F43 space, we have a different shape of the measurement. Probably those originate from there.
So they are too close together. That's been the LV.
But is it then? But these are at reasonably high is it rather high concentration or rather low concentration events when this happens?
It looks
It's
more
in
like a
winter.
period, not like events.
But I mean, these are the points where 43 is low, so probably the SV and the LV are close in this triangle in the 44, 43 plot. Maybe we can exclude these then with the Euclidean distance. So we could keep still all these points in 43 and 44, and then separate based on the distance.
Yeah, but I don't like the distance too much, you know.
You
Like,
don't apply that? Okay.
yeah, because the distance is kind of, you know, you artificially kind of, pull them away. But sometimes it's not.
You take away many good solutions.
Yeah.
So.
Yeah, but I mean here it's then probably if they are too close, then you have mixed always. So we have to also exclude those.
Why? Why should they be mixed?
Yeah, I guess if the 43 is low, then probably this goes then towards, to the LVOA.
No, but like I think if you sort it based on the 44 and the 43,
right?
And then you want if this is go when the 43 is so slow.
Yeah.
Okay, yeah.
Then it goes moves up, I guess.
Might go to the MO, but
yeah.
But like I think. But here you also sort it based on the 44, is it?
Yeah.
3?
Yeah. I think so. We sorted both, right? 43 and 44.
Yes, that's right.
Yeah, that's this also I never understand. Yeah. To sort twice doesn't make sense to me. I mean, you sort it first by 44 and then you sort it by 43. But then
But then it's more for the purpose of monitoring to know what was going on.
Yeah.
Oh, I mean, either you sort it by 44 or by 43, but you cannot sort it first by 44 and then by 43. I mean, if you do it like this, then it's actually only sorted by 43.
43 in less oxidized, 44 in more oxidized.
Yeah.
This is what I mean by twice.
Yeah, but like the thing is, which criteria give it more priority sometimes?
They're considered at the same time with equal weights.
Yeah, when you sort it at the same time, then yeah, I also not quite understand this. Yeah, but like in theory, it should be.
You should only sort it by 44.
Yeah.
But that's anyway in the new
protocol.
Yeah,
protocol.
it is.
Yeah, that's good.
I think that I don't even understand how it's done. I don't think you should do it, whatever you do.
Yeah, I mean, like here in this case, when these are quite small, I think as long as it's not 0, it's still okay. Is it? Don't you think so? Or
yeah, I don't know. I've never looked at such plots, but it's actually interesting anyway. Why there are these excursions to lower values. I mean, there must be a reason for it, but I don't know what.
Yeah,
either there are other sources around, or yeah, maybe I'm not sure what happens there, but maybe still there's something in the primary going on.
We'll investigate further how the 44 plot looks like here for these points.
Yeah, and if these are rather low concentrations, if it's anyway close to the texture limit, I wouldn't worry anyway about it.
Yeah.
And so I don't know. I mean, it's actually interesting, but I think nobody's ever looked at this.
Mm.
No.
But it's maybe if somebody has time, I mean, it would be interesting if this is also seen in other data sets, and then try to find out why this is happening, because it's probably somehow wrong. Yeah? Or I mean, the model is not so good. I would agree with that. I don't know. We don't have a good. We have never done any maximum analysis.
I guess these are points where 43 is really low in this SV factor, but 44 is higher in the LV, and you also have a high 44 in the SV. So it's basically going towards, you know, more or less two LVOA factors.
Mm.
I mean that's what I could imagine. You know, you're still sorting also 44, so the LV is well positioned because 44 is higher there. But then this factor profile here is a surrogate of an LV, so it's probably a second LVOA factor.
Yeah, but it's weird that it's done only for a short time like that.
Yeah.
Yeah, I don't know. That's fine.
Yeah, but anyway, let's try to follow the protocol first, and I will check this plot for my data sets. I think I monitored 43 as well.
Yeah.
So, and we can talk afterwards. And
good.
I think we should move on so far.
Thanks for all the tips and hints.
Yeah. Thank you. I think next is Petrol. Are you here, Petrol?
Yes, I'm sharing the screen, and do you listen to me?
Yes.
Can you hear me? Perfect.
Yes.
Good. Okay, so let's move to Central Europe, to Czech Republic, to the rural background side, which is surrounded by fields and woods. To clarify it, last time was not so clear. There are several settlements spread around. Unfortunately, we have some NOx and BCFF sources around also. One is to the north, southwest and northwest. One is agriculture cooperative, and one is wood processing cooperative. And this is making the data treatment a little bit more trickier. And the main source of HOA, it's about 6 kilometers to the northeast, but the site, it's about 600 meters above sea level, and the terrain is quite hilly. So the distance, it's quite big. So we were treating data from seat of AMS. We were measuring in the beginning with 1 minute resolution, then 5 minute resolution, but for the modeling, we use 30-minute averages. And the measurement covers something like 9 months in 2019, and we cover all 4 seasons. And actually, Ian already mentioned it. We have a problem to get the HOA factor. We discussed it already several times by this presentation. We use different alpha values to differ between the BCFF and BCBB. As I mentioned, we have other sources of NOx and BCFF at that site. So the last step, what we did, we tried again model the seasonal, base seasonal solution, and we set criteria. So first we modeled without fixation and set the criteria that the factor 1, which should be the HOA, have the same time series like BCFF. The time series in the diurnal cycle. And then we modeled also another set was modeling with BBO fixation, and we set 2 different criteria, that the factor 1 is the BBOA, and the factor 2, which has the same diurnal cycle, should be the HOA. However, we haven't been successful. We didn't get a fresh factor which correlates with BCFF or NOx. We tried to also compare the weekly and weekend data sets with the courses of the BC, BCFF, and NOx, and we still haven't been happy with the results. And we would like to support our results, what I would like to present next, with the other studies which were done on the site. These were the studies dealing with OCC analysis, and we haven't seen like fresh traffic emission at that site during different studies at all. So as I mentioned, we did the rolling, the seasonal rolling, and we tried different windows, 7, 14, and 21 with 1 day step. We constrained according the season different factors. We used reference profiles from CRIPA for the BBOA. Then our coal combustion profile, and then we also constrained the MOA factor. We have 2 different profiles for winter and spring, one, and for summer a different one, and this factor should represent H traffic, and which is in spring and winter contaminated with residential heating, and in summer it should be just H traffic. Okay, so we set different sets of criteria. For winter, there was the first factor was BBOA, so we used the time series criterion with BB. The third one was the MOA 1 in our case, which was the more oxidized one. And then the factor 2 was the coal combustion with the fraction 115. And then the last one, the last one was the, if I'm not wrong, the less oxidized factor. Yeah, and it goes on and on. So during the seasons, we have different number of MOAs. We have MOA 1 and 2 for most of the season, except summer, there is just 1 MOA. Then we have LOA during 3 seasons except winter, and the coal combustion factor in 3 seasons except summer. It makes everything a little bit more complicated. So here are the results. As you can see, the 3 factors were constrained: BBOA, coal combustion, and MOA 1. The BBOA and coal combustion, they have very nice diurnal trend, as well on both of these, as well as the third one, the MOA, there is almost no diurnal trend. And you can see that the concentration, even in winter, were quite low. This makes a little bit everything more complicated, and here are the fractions of the factors, so you can clearly see that the MO1 and 2 makes something like 85% of the whole concentration, or the contribution is such high by these two more oxidized factors. And here are the error estimation plots, which according our opinion looks quite nice. And again, the factor contributions and the relative ones, and then the contributions by concentrations for these 3 months of winter. And here is the F44 versus F43 plot, which I think it's not bad. It could be better, but this is the best result what we've got. And here is the spring solution. We've got 5 factors in total. Again, we constrain the first 3. Here we've got also the LOA, and again quite low concentrations, and the secondaries are contributing most to the site. It's very nice that you can see that the coal combustion, also the biomass burning factor, has very nice seasonal trend, like lower contribution till end of the season. Here are the error estimation plots, which looks again quite nice. And here are the relative contribution of the factors and the contribution in concentrations. And this F44 versus F43 plot, it's quite okay, I guess. And here we have summer, which was the most tricky season, I guess. So 4 factors, 3 of them were fixed. So we are lacking the coal combustion factor. And here again, very, very high contribution of these oxidized factors. And more spreaded error estimation plots. And here the relative contribution and the contribution in the micrograms per cubic meter. And F44 versus 43 plot. And last not least, the autumn. There was the interesting thing was also the correction of the data. We had parallel measurement or filter sampling with, and we did the IC analysis, and you can see the differences between the 2 approaches, which are quite reasonable. And here for 4 factors, here we haven't been able to distinguish between MOE1 and 2, but we have back the coal combustion factor, and the same diurnals like in spring or winter. Yeah, and even in autumn, the concentration were very, very low. And again, the secondaries are the dominated aerosols at that site. Better error estimation plots than for summer or I guess winter. And the relative contribution. And here we are a little bit out of the triangle, so maybe there is some space for improvement. And that's it from my side. Okay. Hey. Okay.
Sorry, thank you.
Okay. Just one more comment. We are still discussing with Ian if we should merge the data or the results, and he promised us to look more to the seasonals, but he haven't have time yet, if I understood it well.
So I'm just wondering, how is your okay, let me think which slide is it? So in your winter, you only have one OA? Is it?
We have two, MOA and MOA2. The first one was constrained, and the third one was the one we've got.
Yeah, I'm a bit confused when you say MO1 and MO2.
Yeah, this is the problem, that we have like different number of MOAs during the seasons, and sometimes we have MOA and also LOA, and sometimes not. So
yeah.
And then there is a question if the seasonal solutions are the right one. We guess so, but how you would like to do the combination merging, or how you would like to call it.
Can you show one type of mass spectrum for the winter? Mass spectrum.
Can you maybe zoom in a bit?
Hard to say. I mean, why? Right. Can you zoom in a bit more on the mass spectrum?
Okay. Sorry. I'm not sure if I'm able to do it.
Maybe just go out of the presentation mode.
Okay, just zoom it like this way. Okay, it's too much. It was a little bit slowly.
So the top. Okay. Can you show the 43-44 plot for winter?
Winter?
Yeah, I'm going there.
Yeah, this plot is a bit suspicious.
Can you make it bigger?
Bigger, even bigger. Okay.
Yeah, just no.
Yeah, you mean like smaller?
Yeah, smaller.
Yeah, the x-axis is example, y-axis is too big. That's why this triangle is distorted. But like, you know, for the winter data, here you include the MO and L, right? Only.
Yeah.
Yeah, it's a bit unusual. Yeah, I mean, they usually should start, x-axis should start at 0 and should not be so. I mean, should have it higher values. Anyway, but I mean, it doesn't look like secondaries from biomass burning or coal. Actually, it should be more on the. And if the lines are right, but I guess they are. That should be more like. I mean, the red points. Okay, it's actually true. That's the real winter, and then moves to the March.
Yeah, it's January, February, March.
Also,
beginning of March.
Was it getting warm then in this?
Warmer?
Was it? I mean, was the cold period rather short in this winter?
I have to check it. But you can see that the trends are really like the contribution of the combustion sources are lower and lower, and then it follows, yeah, here. We can check the temperatures. I'm pretty sure that Radek did it.
Yeah. Oh.
But it's for sure that we are not really able to get the HOA in any season, like the fresh one, the fresh emissions.
I mean, how much BC traffic do you have? You know?
There is this correlates with MOA1.
Yeah, but in concentration, how much?
Very low. We probably showed it last time. I'm not sure if I have it here somewhere.
I mean, you could kind of roughly, you could say the HOA should be half of BC traffic.
Yeah, we discussed it already.
Oh, we discussed this already.
Yeah. Here is winter.
It's really low, then I mean, then it's then you can.
Here is winter. These are like diurnals and the.
Sorry, we can't see it yet. I think.
Sorry.
You still see the others.
Yeah. Okay. So let's share the new one. So this is winter.
Oh, it's really low.
Yeah.
Yeah, so that's fine.
Okay.
I mean, yeah, I mean, I would maybe. So the coal factor and the biomass burning factor, where do we have them from? Say again, and BBA.
Okay, a BBOA, it's from Kripa paper.
Yeah.
And the coal one, it's our one. You can see it here.
Okay.
Winter one is fresh ones. We did some combustion here at the Institute property, and we did measurement. It was really like something between emission measurement. And yeah, this was the winter one. So this one is really like coal. Yeah. And this one was the second two of them in the spring and autumn. Radek did like multi-factor solution, and then I think he correlates the BCBB with the factors, and he picked the one which was correlating with BCBB and has 60 and. Oh, sorry, not 60. This was the coal one. So this was like the different MZs, like according literature, according to the fresh profile and so on.
Okay.
Peter, can you show your mass spectra. Because at MJ 115, it seems coal burning CCOA is not the dominating contributor to MJ 115, and seems BBOA has higher contribution to 115. Or no?
Oh, it's hard to get. No, there is, I don't think so, but there was the
variation.
The criteria. Maybe you are right.
Okay.
There was a criteria for sure. There are like several different MZs which are linked with coal, different one. In Czech, people are burning black as well, the brown one. So it's tricky again because the brown one is more like the biomass. And sometimes they burn together coal and wood.
Okay.
I think the thing is what's your criteria again? Is that just 115, the intensity of 115?
I guess for the coal.
No, you should use the explain variation, not just the time intensity.
You mean time variation of the
No,
15?
the explain variation of 115 by the coal combustion factor, if you believe you have coal combustion factor. So it means most if you not sort, but like you make sure this factor explain most of the 115.
Okay.
By using the p-value. Here you just, here you do like in this here that your criteria, it might give you larger 115 intensity, but it doesn't necessarily give you larger. Not most of the 115 mass is explained by this factor, then it doesn't. I think that's what the Trinshay meant.
Okay.
Yes.
Okay, sorry, I didn't understood it well before.
Because you see the black dots there in your CCOA, 115 is not the.
Okay.
It's not the highest.
Okay, so so it should be done differently. Okay.
Yeah, also usually the pH. Can you
maybe go back to the
show the mass spectrum?
Yeah, the pH pattern is not so. I think in high mass it's not so.
Yeah, but the pH are
okay.
They are fine.
They're
They are
effective
high in
No, that's fine.
Yeah.
Okay.
So it's true. So they are actually. Yeah, you should always put a scale also for the right hand side for this.
Yeah.
Okay.
So that one knows if it goes to 1 or what is the number.
Oh, okay.
Yeah, it's true. You have a bit. I would also check if you use a different BBOA.
Yeah,
that
is
profile, if that makes a difference.
You mean use different profile?
Yeah, try like the NG or whatever.
Okay.
It could matter.
I think we tried it. This was the final solution. I can ask again, but I think we did like several profiles, and then this was the one we stick with. Because we had quite high 29, in the profile, and Kripa, she has it also, if I'm not wrong. So the 29 issue here is also a little bit.
I mean, if the pHs are nearly all explained, I mean, nearly close to 1 for the cofactor, I mean, what you could do then, you could actually use the time series of the pHs and then actually constrain the time series.
Okay.
So not the profile. See what happens.
Okay.
Because then you might get also at the low end a very good profile.
Okay.
That's an option. Because I mean, if you do an emission measurement, I mean that's good, but it's also a bit tricky because usually it's high concentration, and then the mass spectra actually doesn't look always the same. Maybe you do it after dilution and things like that.
Yeah. No, it was really not emission. It was something between emission. It was not measured directly by the source. A little bit
you
farther.
knew that it was a high contribution.
Yeah. So, but we can try it with the pHs and the time series, the criteria.
That could be
for
nice.
sure.
You try that for the winter or really the coldest periods.
Okay.
Then maybe you can use that afterwards. We can maybe then also find a good mass spectrum, and then also for spring and autumn you can constrain that time series, that mass spectrum. Yeah, it starts to look better than maybe last.
Thank you. Okay, so hopefully Ian has some time and.
Yeah, sorry about that.
No, it's fine. It's fine. No problem. You are busy. It's okay. Good.
Okay, I think we go to the last speaker, Mina.
Yeah, I tried to find my presentation somewhere.
Yeah. Yes.
Are you seeing something?
Yes.
Good. Do you still see? Because I have plenty of screens, so I'm not sure if I have the right one.
Probably you need to switch the display.
Oh, maybe I can.
You can go to display settings on the very top.
Oh, yeah.
Yeah, swap, and that's it.
Okay, now. Okay, so my site is located in an urban area in Helsinki. It's we call that site like a street canyon site because we have those buildings both sides of this street, and which has effect of the dilution processes. And there is like 3 lanes both direction, and then we have on the middle of the street also tram line. And this site belongs to the Authority of Helsinki Environment, and they are responsible of measuring those EU directed air quality compounds. And we just installed our ACSM in that container summer 2015, and in addition there are some other BC monitors and DMPS instrument. And just to remind a little bit of the sources in our site, so we couldn't distinguish the BBOA in that site, although we saw that the contribution of organic 60 increased during the winter time, and we managed to separate during February, when we had very cold period. We managed to separate like a BBOA spectra. It's in the right hand corner, and we used that one to constrain the winter season, but we still managed to get any proper profile, and also based on the idlometer, the wood burning contribution is quite low, or it's very hard to distinguish because the traffic contribution is so high. So I think also the accelerometer model is not maybe working so well at that side. So we didn't include that factor in our solution, but of course it's maybe a mixture in somewhere in OOA. And this is something just to remind what kind of 44 to 43 ratio is. So this is just the total 44 and 43 in whole matrix. And as you can see in summer, all the points are like not, they are all in the almost same place. So we can't separate any like a OOA, a semi-volatile or low volatile oxygenated organic aerosols. I think we just have one, although it's a little bit different than all the other sites you have been shown today. And whereas in spring we can clearly see that more springer we go, less 44 we have, and more 43 is popping out. And the winter and autumn is also showing something, but not like based on the time. And then we have those settings which we have been using. So we constrained HOA. We use this Sally's average spectra. And then we have this coffee roaster factor, which we managed to distinguish very easily. And we also confirmed that with high resolution AMS mass spectra, and we used that mass spectra for constraining. And then we have normal bootstrap enabled, and we use 2 weeks window and 1 day shift and 50 repeats. And in summer we have 3 factors, and non-summer we used 4 factors. And the list of criteria is shown below. So we were looking HOA and BC from traffic should the correlation, or we use this p-value approach. Also for the coffee roaster, we follow the variable 109, which is very clear in this caffeine factor, or in caffeine mass spectra. And then we didn't have any threshold for those 44 or 43, just they have to be above 0. And we use that sorting criteria for 44. And this is just the average mass spectra of these different factors. And I have some difficulties to combine this summer to this LVOA and SVOA, so I show them separately, although they are very similar ones. And the LVOA is very oxidized. It has a lot of 44, and also this my semi-volatile or less oxidized OOA has a lot of 44, but the ratio between this 43 and 44 somehow indicates that it may be a little bit less oxidized, although it still looks very oxidized. In this less oxidized OOA, we also have a lot of some ions seen in the spectra. And these diurnal trends are shown in the right-hand side, and I guess they are quite typical. I have to check this coffee roaster diurnal trend because I think I may have not plotted like the wrong one, because it doesn't look the way I remember it was, because normally I just saw the peak in the before noon or maybe before afternoon, not that evening peak. So maybe I have plotted some wrong peak here. But basically, normally these caffeine peaks are very sharp one, and they appear in the morning or noon, not in the evening anymore. And the OOA in summer and this low volatile organic aerosol, they diurnal trend is quite flat, but we can see some diurnal trend in this semi-volatile or less oxidized organic aerosols. And this is the time series and monthly fractions. And I don't know what to say. We have a lot of oxygenated organic aerosol throughout the year. The contribution of HOA is quite stable. And also as you can see, the time series of coffee roastery, it's peaking like a couple of those peaks lasted a couple of hours. So they are basically, whenever they are roasting the coffee beans and the air mass trajectories or the wind direction are suitable, then we see those peaks, and then the contribution may be during those couple of hours time scale, they might be quite high, but still the contribution is like overall it's quite low. And then this is the seasonal and monthly concentrations, and also the pie charts. It's again showing that we have a lot of oxygenated organic aerosol in Helsinki, although we have those clear primary sources, but still the secondary organic aerosol fraction is very, very high. And then we have those error estimations. I don't know. In numbers, these errors are not very high, but maybe the shape of the slopes are not very nice, but still, I guess they are okay. And then this is the F44 and F43 ratio, and the left-hand side, I'm just plotting this more oxidized organic aerosol based on a different time of the year. It goes like the summer season is behind all those dots. It's that blue one, so it's below this orange one, and then we have autumn is also a little right from the summer season, and then we started to go from winter. We have a much higher contribution of 44, and then it goes towards springtime, the contribution of 44 decreased. The semi-volatile or less organized organic aerosol, it's a little bit very not very informative. You can see some clear colors that they are somehow in a one spot, but they are very spread. So I'm not quite sure if this my less oxidized organic aerosol exists or not. But if I combine them, then it's not easy to see any trend. That's why I have been keeping those two separately. I think that's all in my side.
Thank you. So here for the right hand side of this plot, those dots are the SVOA point.
Yeah. This is whole year except summer, this right hand side, SVOA.
you're supposed to have to, but where's the LVOA?
LVOA is in the left-hand side.
Okay.
So I have separated these figures to two.
Okay.
I mean, this looks quite different than the. I mean, your dots that you just showed earlier, no? And yet the season-wise.
That's the all. That's not subjected. I guess here is subjected.
Yeah. The first one was just all the like in the directly from organic matrix, the 43.
It was including the.
Yeah, everything. Yeah.
I see.
Just to see some, like to get some indication what we're supposed to have there.
Okay.
So here the green points are the on the left hand side are the
They are winter.
The measured points, but also subjected.
They are from this criteria plot.
Sorry?
These are all the points I have. These are all the points I have chosen.
This you don't show here the actual data. You just show the fact. I mean the LV and SVOA.
Yeah.
Okay. It would be interesting to show also the data. I mean, where you subtract the.
I think I have been. Yeah, I think I have been presenting those one earlier, but this was like now.
Obviously, I don't remember.
Yeah.
I mean, because now everything. I mean, the SV is a little bit surprising that it goes. I mean, that it doesn't stay a little bit more to the right. I mean, but I don't know. It would be good to see what. But that's maybe in summer. In summer, all data, most of the data is anyway. Oh no, that was the total organism. But it seemed to stay in one spot.
Yeah. So it was a little bit surprising that I couldn't get any less oxidized OA in summer, because normally everybody is showing that way. That in summer you can see, but in at least during that year or that summer or with that instrument, it just was very oxidized.
In summer, you just modeled one OA.
Yeah.
I see.
Yeah.
I mean, as if the. I mean, obviously the temperatures are not so high as further south. I mean, when you compare to Switzerland, or so, I think the afternoon temperatures are very seldom very high.
Yeah,
so maybe
that's true.
Maybe there's not so much. I mean, rather local, fresh SVOA. So maybe you have just a tendency just to have. I don't know. I mean, you just have every day you have your emissions, but I mean, the forest is huge, so I don't know. Then it's rather aged somehow when you're further south, where the temperature maybe going 30 degrees or so in summer, then it really kicks in. I mean, these emissions that are rather local. But I don't know. I'm not sure what the. I mean, if we see diurnals. I mean, this. I don't know. I mean, these things maybe at some point when the solutions are more final, it would be good to think about a little more these 44, 43 or SV LVOA plots. But I don't know. At the moment, I'm a little bit skeptical, or I don't know about the quality of all these plots. that they're quite uncertain on some of the sides. So it's going to be not so easy to make a overarching analysis. I have a feeling at the moment. I'm not sure. Let's just proceed. I mean, I think everything looks reasonable. I mean, that you cannot get a biomass burning. I mean, I mean, you could constrain one in winter, yeah, but you are not happy with the results if you constrain something.
Yeah. Of course, I can constrain and I can calculate that with constrained PBOA, but I think I can't explain that results because we don't get clear evening peak. So I guess it's somehow regionally distributed, that biomass burning all over the Helsinki metropolitan area or even larger area, and it's not then maybe.
Is the mass 60 having an evening peak if you just plot MZ60? I mean, the absolute...
like a diurnal.
Yeah.
Yeah, I think I couldn't see that.
No. Okay. So the 60 also doesn't have a diurnal.
Yeah.
Yeah, then it's probably not much local. There's just not much local PBA from wherever the. I mean, are you at the edge of the city, and most of the time actually doesn't come that much from the city?
Yeah, but we have managed to get that with SPAMS, this biomass burning.
Yeah.
So that's why. But of course, it was different time, but still. So it's
Yeah, but if it's not shown in even the 60, I mean, then it's.
And also the coffee roaster has also occasionally this 60 signal, so it's also like a little bit disturbing the.
I don't know. I mean, if the 60 would have been a problem with the diurnal cycle, I would have.
Yeah.
Again, that maybe one can also try to constrain the time series of 16.
Yeah. Okay.
By the PBI factor, but if it's anyway, it doesn't have a.
Yeah, I don't like to force it. Yeah. But I managed to get it without constraining during February when we have like a -20 something, and then I managed to get it, and it was. I think it was good. The mass spectrum was good, but still, it's maybe it was just happening during that period of the winter.
Yeah. Population is small in Finland. Good.
Yeah. Shall we turn on the camera? Do a screenshot?
You want to make a picture?
Yeah. Good. Wait a second. Samira, Mina.
Some fell asleep.
Okay.
No.
Mina, can you open your camera? Turn on your camera. Maybe okay. Francesco, can you turn on your camera as well? And also Julia. Okay. Anyway, just do it. Good. All right. Very well. So I guess thank you guys for tuning in today. I think as I mentioned this morning in the very beginning, we need to work quite tough and to catch up the deadline, and hopefully we can all finish it. But of course, I will try to support you guys as much as I can. So I will send out the emails to each one of you who need to have a regular meeting with me, then hopefully we can manage this by the end of this month. And yes, so I think some of you already in the WebEx group. So I have created a WebEx group, WebEx team group to let you guys to ask question anytime, so I can respond as fast as I can. So in there, you don't need to write the email for every question, and it's informal conversation should be more efficient in that, in my opinion. So yes, I will maybe send you guys a link to invite you to the team. Then let's sprint a bit to finish this on time. So yeah, I guess that's from my side. If anyone want to comment on this.
When is the next meeting?
It's December 15th.
Okay.
It's settled already.
And what is the goal until then? Maybe you can remind everyone.
I think the next meeting will be more about the editing of the papers of the first draft, but I have to get the most of the preliminary results by November. Then I can have some time to look into it.
Okay, so you should maybe send around another mail, because not everybody's here.
Yeah, sure.
That you would like really to have the best results people have by the end of November, so you can start thinking about
the
figures for the paper.
Okay. Yeah, so maybe we finish here, and I will send you guys an email to remind you guys, and thank you very much for all the.
Thank you, Ian. I think you're doing a good job. Very good job.
Thanks. Okay. All right. Have a nice.
Bye. Have a nice weekend.
Okay. Have a nice weekend. Bye.
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 Hi, Ian.
Yes.
Have you ever thought about plotting the F44 versus F43 in this kind of 2D histogram?
F44 versus F43?
Well, which way now? 44 versus 43, like the triangle plot basically, but in this 2D histogram. So like for one season, and then you could have like color codes by the number of counts you have in each grid, like kind of gridding the data, so you don't have points behind each other, so you can actually see where most of the points are located.
Yeah, that's a good idea. We can.
Yeah,
I will check that.
Yeah, I can also plot it because I'm playing, but you can go. I see you are busy.
Yeah, I have to run today. So okay,
Yes.
thank you
All
for
right.
the suggestion. Though.
Talk to you.
See you later.
No problem. Okay. Talk to you later.
nice
Bye.